All right, what are we doing? Welcome, welcome, welcome. We're working more on this module. It's a big job. It's a lot of stuff that I got to get together, but it'll enable me to test stuff, which has been something that I've been incapable of. I've needed to hook up multiple modules in order to test things out, and then it's like, do I have a gate signal out of this? Not really. So, do I have an arpeggio? Do I have like a sequencer of any kind? That's what this is going to do. This is going to do all those functions in one, and enable me to have a separated setup that allows me to plug in modules and get them all tested and stuff. So, big piece of capability here that we're working on. It's not a small task. There we go. We got everything running there. Dusty scope. Why is my scope so dusty? I think just because it's the darkness of it all, and I think that screen protector collects dust. Yeah, it really does. Jeez. It's like my car's electronics collecting dust. Oh boy. Yeah, I redid the hookup over here, and we're gonna continue with it a little bit. I need to hook up all the digital stuff, so I need the channel select, and then I need the I2S audio to go into the microcontroller, and we need to assign all of that stuff, set it up, and then test it out. Should go pretty smoothly today. We'll have a nice chill out build stuff stream. Let me just check over here. I did all of my next and end cards. Nobody really uses next. Julian Champion, how's it going? How you doing? How's your Thursday? I didn't get the garbage out today. Oh, I need to do YouTube. That's right. At Oh Bother VOD, and let's get the YouTube chat up here. Module tester module tester module. Pop out chat. Bonk. We had a family member come over today to pick something up, and Willow was being a total ham. She is just off the charts when a new person comes in. Usually it's like my friends, but if it's an adult male, she goes nuts. She was looking up at him with her ears back and going, "How you doing? Hello, hi." And then she was rolling on her back and stuff like that. I'm a YouTuber too? I do. I'm actually streaming to YouTube right now. And then with the YouTube stream, since YouTube doesn't have like a fixed chat room, because Twitch kind of grew off of IRC for their chat, which is a good idea because the IRC protocol is really good. But excuse me, what Twitch does is it assigns like an IRC room to your chat. So if you have an application that's popping out the chat, or doing something specific with the chat, it's always the same address. With YouTube, they spawn their chat rooms off of the YouTube video, and so the address changes every single time. And it's just this big alphanumeric designator. And so I can't have an automated thing pop out the chat. So what I have to do is pull up my own YouTube video, go into the chat, pop it out, and then I can close that video. Very annoying. Very, very annoying. Whereas with Twitch chat, it just opens up an automatically popped out chat. It's always funny, like when I leave stuff around, sitting around on the desk, and there's like a particularly large cleanup session, these things will be sitting with like a bunch of important wires in the jaws, just sitting there. That really, that scares me. Even though I know I'd have to actively go over to it and pull the trigger on it in order to cut a wire, just having that sitting there with a bunch of wires sitting in its maw is creepy. Let's get the scope off of the screen for right now. I do need to clean up this desk a little bit. Progress has been very slow on projects. It's kind of really annoying me, and it's filling me with trepidation. I'm getting like project anxiety from the lack of progress. Not to say that we haven't been making progress, because we've certainly been making progress. We're much further along with some of this stuff. But I see other channels finishing stuff, and I get jealous. You shouldn't compare yourself to other... No, I should. No, I should. I should hold myself to task for things that I'm not doing. Like publishing 100 YouTube videos, 100 VODs that I still have to publish. Leading up until they started allowing us to dual stream. That was like a year ago, wasn't it? That was a while ago. I am very tired. I woke up at my desk last night in the middle of the night. I hate it when I do that. I gotta like prioritize getting good sleep tonight, and maybe I'll feel better about everything. Maybe I'll make a bunch of progress. The thing that's really gonna hold this one back is all the coding that needs to be done to get it working. There's gonna be a lot of software that has to go into this thing in order to make it viable as a testing machine. And then hopefully I'll get it to a point where I can leave it alone. Maybe do an update at some point, but I need it to get to a state where I can then double back on Dave's module and some of the other stuff. What's the thermal camera for? Because it's cool, and we do soldering on this stream. My moderator prioritized getting me a thermal cam, and we kind of worked together in order to get it together. It's from GroupGets, and it's just a thermal webcam, which is important because the thermal webcam has good frame rate. It has an approachable frame rate that makes it look good. Thermal imaging has come a long way since we originally got this thing, but the thermals are there because we deal with heat a lot. Electronics has sort of a close relationship with heat. When you're testing something out for the first time, or if you're just soldering, you're dealing with heat a lot. And he got kind of sick of me probing the temperature of stuff with my fingers. I still do that, but he got annoyed at it, and that's what prompted him to prioritize figuring out a thermal camera. So what we did is we built an open source thermal imager, and it sucked. The processing was not fast enough, and it was like this low frame rate and low quality. The advantage to the other one was that I could point out things on the desk and get a temperature reading from it. Like this, the GroupGets thermal webcam module is not all that advanced. If I can learn STM32, I could reprogram it to do a lot more cool stuff, which is something that, again, just hasn't really jumped into the forefront of what I'm working on lately. Hey, Keeper of Maps, how you doing? But yeah, there's a lot of very, very cool stuff that we do with heat on this channel. So aside from just viewing my veins, see where the big vein is. Now, those on YouTube are not hearing music, or watchers of VOD are not hearing music because it's being separated out in the interest of not getting myself arrested for using audio frequencies that are not allowed. I hate that compromise that Twitch made. I really do. I wish we were able to just use music, because it kind of takes something away. I mean, I know there were channels that were just running music like constantly, as like they were playing the game, but then they also had their own music playing, which is, you know, that is kind of bad. I use it as intro. I use music as intro music, but like, man, need a heater coil on the orange 3D sign. Just like have a little hot air blowing on it so that it pops out. It'd be kind of fun. I mean, it is, you know, I am stealing these songs, but these songs are on a free mix that's on the internet. I guess rebroadcasting is still a no-no, but how come, I don't know. There's so many other things that we could worry about as a society. We live in a society. There is just so much mess on this desk. Holy shit. This mess, it is not blessed. Bam, 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 bam. What the? Did that just skip? Wow, it skipped like the whole intro to the song suddenly. What is that all about? That's abrupt. I didn't notice that at first. Didn't know that was part of the mix. It's just like a garbage pile at the top of the desk. It's like just garbage. This thing has been a lot of work though. So far, I've gotten 6 output channels working, and I've sent those to op amps that make them into the plus-minus 10 volt region. We've been able to mux the channels, And now we just need to hook the mux up to an amplifier, an op amp that'll lower the voltages down to 3 volts, which is the input for an I2S receiver, 2-channel receiver, that will then plug into the micro and get some stats. We'll get some information about the signals that we're transmitting around. Right now, the op amp has a fixed resistor on it. I don't know whether or not I want to put a potentiometer on there. It's probably a good idea to put a potentiometer on there, because that way I can dial it down, because it's not 0 to 3.3 volts. The input amplitude that the analog to digital converter likes is 0 to 3 volts, not 3.3. But that'll get us audio into the microcontroller using I2S and the internal I2S system that the Teensy uses, and it'll allow me to do all kinds of cool analysis stuff. We'll be using serial prints in order to figure out what our waveform is like. What is it like? Who is it hanging out with? You know, that kind of stuff. It'll be pretty cool. I think so, anyway. I've had way too many spicy things over the past week. I had bulldog noodles. I've been spicing things up way too much, and my stomach is doing somersaults from what I ate yesterday. It's terrible. Too much spicy. I'm going to get an ulcer for all I know. Just way too much spicy stuff. I am a wreck. So I'm dialing back the spicy stuff. I had a pork roll, well, leftover pork for lunch, and I'm keeping it nice and bland. The bulldog noodles that I had were habanero lime, and I'm growing habaneros this year. God, it's gonna be terrible. I'm gonna make it like a sweet relish out of all of the peppers that I'm growing, and it's pretty popular with my friends, but this is gonna be a habanero one, so I'm gonna have to wear gloves when I cut that stuff. What I do is I sit down at the end of summer. I sit down with all the peppers that I've grown, because I'll freeze them, and then, you know, the plants still grow peppers, and so I have all the peppers that I've grown all year, and I sit there and I chop them all up into little tiny bits. And I have not in previous years worn gloves. I said, you know what? I'm not growing habaneros this year. Why do I even need to wear gloves? Chop up all the peppers, and then for 2 days, I'm like, my hands are burning. Like 2 days. 2 days, I have chemical burns on my hands. It's like a subtle pain that just lingers. So this year I am gloving up for that. I'm definitely wearing gloves. Tired of my 9-month-old puppy pooping and peeing on my floor with Willow, my corgi puppy. And if you want to see Willow, there's 10,000 pictures of Willow on the Discord. On the Discord, I have a pet section for posting pictures that you took of animals. So you go to the zoo, you take a picture of a giraffe, you can post it there. If you find a picture of a giraffe on the internet, put that in the funny section. That's it. That's the rule. That's one of the very few rules that we enforce on the Discord. So the pet section is for animals you've seen and taken a picture of. Anyway, lots of pictures of Willow in there. The way that I got Willow when we first got her home, the way I got her to start peeing outside, because really you need to initiate, like the dog needs to pee outside, and then you positively reinforce the outdoor behavior, right? So you give her a treat, and then eventually you don't give her treats and she just knows to go outside. With Willow, it did take a little while. Like, you've got to just get used to the cleaning procedure, right? It actually took a long time for her to fully get it. Now she fully gets it, and the only time she'll go inside is with emergencies. But how do you initiate that? How do you get the dog to go outside the first time? Well, it was a rainy day, and I'm like, please, Willow, just go to the bathroom. I need you to do this. She wouldn't. And this is in our backyard, so I ended up pissing in the bush. And she saw me pissing in the bush and immediately peed right there on the spot. And I was like, that's a girl. Lead by example. Piss outside. That's my advice. Go take a shit on the lawn. Listen, we live in the woods here, and the woods is just a big toilet. If I were in the city, I would be a little bit more reluctant to pee, but I led by example. I'm a leader, not just a manager. God, my glasses has made this section of my ear that's like a little bit damaged. I don't know what the deal is. I'm like picking at it. I gotta not pick at it. I'll have to put some Neosporin on it or something. Yeah, Willow took a while to fully get the message. You know, there were times when the weather was bad, or you know, she would just pee inside. Being in the forest is completely okay, but pooping, usually bury that. Yeah, you grab some textured leaves that you're sure aren't going to cause a rash, and you go and you bury the poop, make a little hole. But I don't poop in the forest generally. We would work on cars at a friend's house, and they had a lot of woods, so we would just wander off and piss and then come back. It's fine. It's nature. The sultry tones of yacht rock. Yeah, we're gonna figure this thing out today a little bit, and we'll be able to play with I2S. I'm running out of space on this breadboard. I mean, I could have tried to make things a little bit more compact. I could break down the power section and move all this stuff like down to here. I haven't really done that. It's good to spread out, you know? We'll have to take this piecemeal and maybe break down sections. I'm not sure. I mean, the low voltage DC stuff being up here, I can clean this part of the breadboard off and have all the low voltage DC stuff up top. And that would enable me to do the port expander and the screen. Those are the remaining two elements. We need to get this thing chooching away at all frequencies. That's the whole point of a stress test. I want serial going to this, I2S going to this, 3 channels of I2S, technically 4. I2S coming back in from the A to D, and I want control over what channel we're listening to, and I want the rotary encoder to be functioning along with the buttons and stuff. And then we know if we know the microcontroller can handle it, but then we have confirmation that it'll be able to do everything we want it to do. This is sort of clarifying what the plan is. We didn't know that we would only be able to run 2 channels, for instance. Do you have any advice for me about how I can make my own hot plate? Why would you make a hot plate when they're $5 online? You can buy a pancake, like a skillet. I bought one of these, the little square ones with the big aluminum top, and it was like $30 or something. If you're making your own, I mean, you can make a pretty comprehensive hot plate on your own. I'm not sure. I've never done it before. I would assume there's a specific type of heating element that you would use, and then you'd want to make sure, like, don't skimp on safety with something like that. You definitely want to make sure that you're running one of those temperature disconnects in case there's a fire. Those things are relatively cheap. All appliances have them. It's like a little wax thing with a spring, and when the wax heats up, the spring disconnects. Hot enough to melt plastic. Well, plastic can melt at fairly low temperatures if you're, yeah, you can probably achieve that pretty easily. I mean, it's like the hardware to do something like that is not complicated. It's very easy to come across, and it's not going to be in too complicated of a build. You get a little temperature controller, a little PID temperature controller, and plug that into the wall. Resettable ones with a bimetallic strip. Interesting. Well, there's hot plate melting plastic, and then there's cutting plastic with a hot wire. Either way, you should be wearing a respirator too when you do that, because there's some nasty fumes that come off the plastics. That's what I use my breaker for. Don't skimp on safety. Just don't do it. It's not worth it. Hospital's expensive. The parking fees, yes. Absolute highway robbery. Oh, I see. You're from Canada. Yeah, must be nice. Must be nice. So yeah, whatever features this tester has, we're gonna have to replicate. but we got to do it from the ground up, I guess, because we're taking a complete departure from the design of this device. We did take the 6 in-outs to heart, though. We did that. Yeah, it's a looks like YouTube notifications worked. Oh, that's good. I'm gonna burp. I burped. Yeah, it's kind of vague what you're trying to do with melted plastic. I've never had like a puddle of melted plastic to play with, but I don't know what kind of repercussions there might be in terms of fumes and stuff if you're like melting a toy. I don't know what you would do with a hot plate and plastic. That's because the stream hasn't started yet. Somebody's always got to ask. It's like the universe needs that. It's like a law of physics that somebody needs to ask why stream hasn't started yet when stream is already running. But it's how all of the YouTuber, how all the Twitch streamers do it. It's not that complicated. It just means that I'm not working on actual stream stuff. I'm just chewing the fat with you guys. Another thing I'm probably going to have to do is take the code for the screen, the commands, take the commands raw and send them out with the software serial, because for some reason the libraries for these screens, the ones that we can find, just use bit banging techniques with delays, which may not be bad for most projects, but since we have I2S running, the I2S subsystem would get hamstrung by those delays. The delays stop the processes from happening. I think we might have multiple threads on this microcontroller though, so that's kind of cool. But like this code will interrupt with the screen, so I'm going to have to manually go in and mess with this stuff and probably use the startup procedure and some of the commands from these libraries. It'll be a little bit more purposeful and a lot more annoying to deal with, but it's what we got to do. Try to reduce some of these pages. We have way too many pages open right now. Way too many. Look at the size of that microcontroller. This thing is crazy. Crazy. What is that speed? CoreMark benchmarks. What the hell? 1, 2... They're like 4 times faster than the TNC 3.6. The 3.2 is all the way down here. Insane. Have an MCU specifically for driving the VFD. That's another idea. I don't think we need... I mean, look at the speed of this fucking thing, right? I don't think this thing is going to slouch in any way, shape, or form. I think it'll absolutely be able to drive everything. Now, having a dedicated MCU just for the screen, that's not that out of the question, because if you have, like, one engine that's running all of the I.O. and stuff, and then another one would be running the screen. Like, that makes perfect sense, and you'd have them just communicate numbers back and forth for like, oh, what's the frequency on this thing, you know, blah, blah, blah. Where do I display, how do I display this variable? Oh, it's that value? Okay. You know, you could have a little back and forth about that, and then the other thing is free to do its functions. I would understand doing that if I was using like a regular Arduino, like an Atmega 326, would probably need something like that, but this one does not. The TNC4 can absolutely do all of this, and if we really get pressed, we could run multiple threads. Pretty crazy. This is the sultry saxophone part of the mix. Atmega 328. I guess I'll leave this one open. This we do not need. This we do not need. This was our example for the 3904s. The MMBT 39. The 3904 is a Jelly Bean transistor. We discovered that this does not affect the input line in any way. So if we apply the transistor gates to our audio, we can still sense those without affecting audio. So we'll have 6 of these things running on each of the channels. Oh, are you trying to get copper out of wires with a hot plate? TNC4 for frequency counter. I've been considering a Pi Pico, but I've discovered that I have a need for simple frequency counter and don't want to spend $500 on a bench unit. Well, yeah, you're going to have to calibrate it, I guess, versus the bench unit, just kind of knowing that the bench unit works. But the TC4 certainly seems to be fast enough. I don't think there's any doubt that it's not fast enough to be getting frequency counting information. Are you going up to RF frequencies? Because that's when things get a little squirrely. And alternative hardware may be necessary. Wait, I wanted that data sheet. How do we park the MCP 6002? Utmel. Sounds like a Star Trek villain. Oh, measure frequency of unknown crystals. Man, what did, like, as a society, we really messed up crystals, didn't we? They don't have any sort of, there's like zero standardization when it comes to crystals and their markings. It's a mess, it's a nightmare. All right, so how do we park an unused op amp? This thing takes 2 channels in, but we're only running 1 because it would be too much circuit building for our breadboard to do 2. And if we can receive 1, we can receive 2. I have it set up as an inverting amplifier that's referencing ground, and I think that's just what you're supposed to do. You just put a jumper on 2 of the pins and then put another one to ground. They didn't show it in this data sheet. Some of the op amp data sheets teach you how to park an op amp. I think Mutables parked one. Did they park one in Edges? That's not parked. It's very frustrating if you have an uneven number of amplifiers. Of course, if I do have an extra amplifier, that means that I could invert my -10 reference and have a +10 reference, and then have plus minus 10 volts on the extra 2 pins of the max muxes, meaning that I would be able to calibrate things from those 2 voltage sources. I don't have anything. I don't have anything. Nothing. I have nothing. Bump, bump, bump. Burn it. Yeah, all right. So there's the no parked ones. I think we're okay. Already been removed from the wire, so it's insulation for the wire. This is a confusing application. I mean, how much, like, do you need to use a Teensy for that? Measure, what would it be? One of these things, just like a $20 LCR. I don't know what frequencies they go up to. It's probably kind of pathetic. I mean, or you could make something with a Teensy, but the Teensy's like $30. None of those would do it. Is it like a high frequency? Yeah, these probably are pretty pathetic. How high of a frequency do they go up to? Detecting NPN, PNP, blah, 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 blah. Resistor capacitor. Measurement results represented by TFT graphics. Power on-off operation. Zener diode. Display. Diode, Zener, triac capacitance, resistor, inductance, battery, power mode. So it doesn't actually measure any crystals. Yeah, I got one of them too. I bought one recently, not this one specifically, but I bought one recently because it can give you the stats of your transistors. So I was able to use it to kind of match transistors decently well enough. Why is there a French fry on the desk? Where did this come from? And this one isn't even like, it's got like potato skin on it. What the fuck? Where did that come from? Weird. Yeah, none of them measure frequency. Why was there a French fry sitting on the... That's very strange. Yeah, the one I... Yeah, it auto-muted me. All right, I'm back. OBS crashed when I click on scenes wrong. It crashes OBS. I don't know why. It tries to pop out the scenes window that I use in order to select all of these different camera angles, and then it died completely. Everything is not fine. I need to calibrate the cameras. So hold on, let me go through that. That's a whole process. Properties, and then I go to FPS type, and I go to 30, and I click OK. And then I go to the properties again, and then I go to configure video, and now I can set it to 4300K-ish. Let's check to see. Yeah, it seems to think that the aperture and stuff is totally fine, but it's not. Where's the gain set? Gain is set too high. So we set down the gain a little bit, and now we have nice lush imagery. But I then have to go in again, go to properties, and then set the FPS to highest, or whatever. Yeah, highest FPS. Okay. See, and then it forgets all the settings. Dumb. The video, gain down. I don't know why it thinks the gain should be that high. It just tries to automatically do everything, and that makes it look like shit. There we go. Sometimes this one's okay. That seems to be just fine. It's not autofocusing. No autofocus. All right, my bright red hand. This one is a parked camera for now. You can see all the parts that I'm collecting for the POS CNC, which is my point of sale CNC machine. Wait. Oh, there it is. Okay, yeah. The point of sale CNC machine. I'm using a cash drawer to hold all the electronics, and we're going to use servo motors because I've got them. I've got these really nice, very high precision servo motors that I would like to use with belt reductions on a CNC machine. So it'll be able to move very quickly, but it'll also be able to move very precisely. And I'm mostly building it out of trash. Although I did buy Open Builds. Open Builds is a wonderful website. If you guys haven't seen it before, they have very, very cheap. If you're in America, they have very, very cheap 2020 rail stuff. Like all the motion stuff you would need to build a CNC, for instance. It's nice and cheap. They're going to be building me my desk when I can afford it. I'm going to buy a bunch of 1500 millimeter rails from them and cut them up with a chop saw and then build my new desk out of it. That's a long time coming. I should have built that one by now, but I've been too distracted on other stuff, including but not limited to the high priority thing behind me, which is burn the subs. Typically on this channel, subscribers on Twitch would get burnt with a blue laser onto a block of wood, and it makes for some wonderful comedy because there's some really weird names on Twitch. Some truly deranged people making screen names and finding them and gifting them subs and getting them up on my board. It's funny, that whole process. Progress. I have recessed. Couldn't figure out OBS. It's not that bad. I know some people who are running like the first version of OBS still, because if it works, it works. I do need to update. I haven't updated in a little while, but OBS isn't that bad. You just have audio sources and then scenes, and the scenes are made up of a bunch of different elements in here. So the elements of the scene are audio, overlays, my Streamlabs that's on top of everything else. I really need to move away from Streamlabs. I think at some point, I should just blow up my OBS and start over. What up, esports? How you doing? Good to see you. Good to see you. I should just blow up OBS and start over. It'll probably take me a couple weeks to get OBS back to where I have it right now. But right now, it's kind of it's a little bit too old and tired. And then if Flatulent Gonad had its way, I'd use Sammy Board in order to coordinate a bunch of the different visual elements that come together to make stream. Every time I open OBS, I get scared I accidentally start a stream despite having the confirmation dialog enabled. My worst fear was, it happened earlier, I clicked this right here, the top of the scenes bar. Now, during stream, I am in here, right? I'm choosing my angles, I'm flipping this from thing to thing in order to give you guys sort of the rich visual elements of this stream and keep it fun and exciting and all that stuff. So I'm constantly clicking over here. If I click this right here, this top piece, and I drag it, even just a little, OBS freezes and crashes out. It's a nightmare. So that just happened a couple minutes ago, but it's terrible. It's awful. Wait, what the hell is that? Oh, geez. Kung Fury. There we go. Okay, now I've got all my window elements up. I have to have a Twitch chat popped out, but then I also have to have the Twitch dashboard giving me stats on stuff, so I can see if my bitrate crashes or if Twitch is having trouble or something, you know, of that nature. There's a lot of stuff to monitor when you're streaming. This is kind of pretty involved, if you ask me. The elements going in, but yeah, I would really like to reorganize. I guess the multi-streaming output is, I don't know if they've put that into the main Twitch yet, so I'm using a plugin for that. I have a webcam plugin that's long since expired. There's just a lot of stuff in my Twitch that I kind of need to rip out and redo. Rip and tear. But what I'd lose if I blew away Twitch, I'd lose my audio filters, and I'd have to rebuild those too. These were a trip to get together. This is the compressor, and then I also have the EQ. Or no, that's the EQ. This is the compressor. So the compressor and the EQ work together in order to give my signature dulcet tones to you guys, the audience. These signature dulcet tones, thanks to the frequencies that are being emphasized or de-emphasized subtly. I don't know if there's a de-esser, it certainly just blew up. Subtly giving my voice out to you guys through this lapel mic. Lapel mics are very tough. If you don't do a lot of audio engineering on them, they sound like you're in a paper towel tube. Or for instance, for me, just handling my beard was enough to get high, like heavy scraping noises on the mic. In addition to that, I run a specific compressor, not as you normally would. It is good that you get louder as you get loud without clipping, but I sometimes use power tools. And so what I have is I have it emphasize my soft speaking voice and then de-emphasize my yelling with a cutoff of volume. So I get loud, but your speakers don't explode. Very important element to have that a lot of people don't. The ability to get loud and not blow up people's houses. I definitely know I'm not talking to an AI character. That would be I guess it's getting better and better as time goes on, but that delay, that big pregnant pause that you get before AI responds is a good tell. But it's getting harder and harder. Sound is very good, thank you. I've worked very hard on it. And I've got it like triple backed up. I've got it even written in a physical notebook what the values are. What? What did manhandling your iPad? How did the screen break just from touching it? That's scary. Don't clean the glass in your house. You start polishing your windows and they all explode because you're too strong. Pick up a glass drink and it evaporates. Fucking explodes into a million pieces. Yeah. quoting Steve Jobs, you're handling it wrong. Don't touch the antenna. Again, we learned another tidbit of information about the efforts to make audio sound normal due to microphone proclivities. Haha, I live edited that. Yeah, there's a lot that goes into something like that. I mean, sound is a unique little thing. Actually, I'm probably picking up the music, aren't I? And this music is kind of loud. Sorry, everybody, that should be a little quieter. I forgot that SoundCloud is a little hotter than YouTube. This should be like down here. Okay, there. I mean, we would have paused it to start actually streaming. I just don't mean to be shouting over music while I'm doing this. It should be pretty soft, and my voice is pretty soft, but groped it. It's just as its own thing, just popping up on my chat. Oh boy, I need to move the fan a little closer. It is 90 degrees and 1,000% humidity today. It's going to be 97 degrees out there in heat wave number 4. Right now, we're in the era of individual heat waves. I have this feeling that either next summer or the one after that, we are just going to be in one big heat wave. The whole season is just going to be heat wave. A crack on the screen sometimes doesn't do anything to the device. Like, for instance, the Pixel 6 has a glass protector in front of all the screen stuff. So I have multiple shattering events happening on this phone, and I've been too lazy to replace the screen. In order to replace this protector piece, you have to go in with a wire and actually break a glue, that like an optically clear glue that holds the two pieces together. It's an ultraviolet glue. So you have to break that down, and then you're able to replace the screen. You have to put down new glue. I've not done that. Not only is it humid outside, nearly 55%, it stinks because of the smoke and smells from the Salton Sea. What is that? I know there's a shit ton of fires out west. I never knew that y'all had to deal with fires out west. That's crazy. Like, oh, it's smoky out today. I'd better put a filter on a box fan. Wild. All right. You get started. Oh, you're near Desert near Palm Springs. Okay, now I know. I don't read chat. The problem is I read chat from the bottom to the top. I often, like, if I'm not thinking, I'll just read the latest chat message. And so I'll end up going from bottom to top, and then I don't get any context. And I'll be like, why would you say something like that? How dare you? And I'm like, oh, wait, you gave context just above. I've had the iPad for about 9 years, and you only just broke it? That's some wild shit, man. I don't know what I did to contribute to that, but watching Bother and going, blowing your iPad up. All right, let's get started here. Get that out of there. Fade out the music. Don't look all the way over at that screen because it's not a flattering angle. Look at the camera instead. Hello, welcome. What are we doing today? Hi, we're working on the module testing module. We're testing the module testing module. We're seeing if our microcontroller can handle everything that we have to throw at it. What I need is something that is able to fully utilize any element of a modular synthesizer. So I need to be able to take a modular synthesizer module, plop it down on my test setup, plug it into stuff, and have it do its job and observe it. Right? So I need a bunch of different functions because modular synthesizers are made of a bunch of different stuff. That includes MIDI, oscillating, audio, control voltages, blinking lights. We need all kinds of stuff. And I have all kinds of stuff. I basically have everything I need to build the module except for like the software and everything put together. So we need to put everything together and then we need to figure out the software. The question when you're doing something like this is, what microcontroller do I use? Well, this is a one-off build. This is a one-off build. I'm building this for me. I'm not selling this or doing anything like that, so I can use the nicest microcontroller I can get my grubby little mitts on. That happens to be the Teensy 4.0. I could use a 4.2, but I think that's a little bit much. You know, at a certain point, you kind of get embarrassed at all the functionality. But I decided to use the Teensy 4.0, right? Teensy 4.0, super duper 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 powerful and fast. The question is, can we get audio in, audio out, serial screen display, serial output via USB, I2C port expander? Can all of those functions live within this little house and not collide with one another in a way that makes it not function? The big thing that we're dealing with is interrupts. If a library that we happen to import into the microcontroller uses delays, that stops all functions of the microcontroller for a certain amount of time. That's really bad when you have other libraries running a stream of data out, in and out. So we need to get all of these different serial things functioning all at once, and that's what we're building towards doing. What I've done so far is I've plugged in 3 I2S audio output modules. Now, I could do 4. The 4th channel, or rather the 2nd channel, is on the underside of the PCB for the Teensy 4. I don't really want to use those pads that are underneath the microcontroller, underneath the development platform. So I'm using the outputs here, and we're using output 1, 3, and 4. And those are both 2 channels. So we have 6 channels of audio output. 6 channels of audio output going into a bunch of op amps that are adjustable in order to get them to be, instead of plus minus 3 volts, these are now plus minus 10 volts. So 6 volts peak to peak, plus minus 3 volts, 20 volts peak to peak, plus minus 10 volts. And that is good for sending control voltages to just about any synthesizer. On the other hand, we have now used up one of the I2S, the audio channels, the specific, very fast, very capable audio channels. We've used up a bunch of them running these digital to analog converters, right? Now, we could use like a whole codec chip and have 8 channels in and 8 channels out. That would be really cool, but I'm not going to go through that because I've got these. These are $11 for 3 of them, so it's pretty cool that we can do this. It runs these channels brilliantly. They make some very coherent waves coming out of it. We can do voltage level signals. We can do gate pulses. So every output is now handled by these 3 I2S devices. There is another channel, however, on the Teensy 4. There is a second I2S. Mr. President, a second I2S has hit the microcontroller. This has a second channel, and so we're going to use that as an input. We only get 2 channels of input. Well, lucky for me, I worked in medical engineering for a little while. I'll make that connection. I used to, or at one point, I had a job where I was redesigning an optical brain scanning probe. It was something that you strap to the front of your head, and it would monitor activity and utilization of blood to your brain. Your brain kind of divvies out the amount of blood that it uses depending on what you're doing. So if you think really hard about something, it is actually, imagine having a job. Yeah, no, seriously, that's me at this point. It actually moves more blood to the front of your brain, right? So we could measure that. And the way we did it was with a bunch of optical probes. So you have a near-infrared LED and a ton of optical probes. And the way that we switched from optical probe to optical probe was with the MAX 308. Maxim makes a lot of like application-specific integrated circuits. They're expensive, but I have a ton of these things in my repertoire, in my box of parts. This switches things that are plus minus 12 volts. It actually goes up to 15. But this does plus minus voltages, and it does it brilliantly. We actually observed the OG wave and then the wave that's coming out of the Maxim on the scope, and there was almost 0 delay. There's barely perceptible delay to a modern oscilloscope, which is amazing. My Limbo system, Limbic, and that's the wrong system. We're talking about I don't know what the specific name it is. I don't know the specific name of what the cluster of capillaries and veins are, but there's something at the back of your brain that divvies out the amount of blood to different areas of the brain. It's kind of crazy. Your brain always uses about the same amount of blood, but it puts it in different places. But anyway, the point is that I've got a bunch of these switching elements, and these are really good at switching audio level signals back and forth. So the 2 channels of observation that we have can be applied to the entirety of the 6 outputs selectively. We can select, we can bop into a channel and observe it. And so the capability of that we're not too keen on yet. We've got to test it. We've got to see how that operates. So that's what we're setting up here. Right now I've got my audio channels coming out of these. I've got them going into the amplifiers that have been set to multiply it up to 10 volts. And then we have those 10 volt signals all going into my Max 308 that's not hooked up digitally yet. And then that goes to an MCP 6002, which is a 0 to, I think it can do 5 volts, but we've got it hooked up at 3.3 volts. So we have this one hooked up at ground and 3.3 volts, and that's taking our plus minus 10 volt signal, shifting it on the number line, inverting it, and then reducing it so that it's a 0 to 3 volt signal. It goes from ground to 3 volts, and it's DC. This thing can handle 3 volt peak to peak AC, but it's not necessary. This thing will also keep us from blowing up the input by limiting the amount of voltage that it can output. So that's running into there. This thing isn't quite hooked up yet. I haven't done the I2S hookups back into the microcontroller. So we'll have the microcontroller spitting out I2S, controlling what channel it's observing, and then observing something about this. It's a mess, but this is all the AC stuff. So once we get all of this running, I can then add to it the port expander and the screen and see if it blows up. I don't suspect it'll blow up, but still. So we need to hook up I2S2. So I'm going to do that. So that's where I need this image. I2S2 is going to exist coming out of out 2, left, right, clock 2, I don't know, BCLK, clock 2, and then, well, out 2, LR clock, BC2. I think that's it. I think those are the 3 pins that I need. I2S basically puts audio information in an I2C-like signal, and it streams that audio information, but then it also streams it for left and right. So there's a left-right clock that switches you from left to right, and then there's the data stream that's always outputting. It's kind of complicated, but you can get high-quality output running to various different types of things. You know, something that speaks I2S is, you know, you can send it to a microcontroller, or you can send it out of a microcontroller, that kind of stuff. You can have multiple different chips from different manufacturers that all speak this language. I'm gonna burp. Okay, I burped. There's a streamer that I know that openly burps into his microphone. Actually, there's 2, and I hate it. I hate it. It's so rude. It's so rude. I get all in my panties all in a knot every time they do it. I'm like, you animals! What is wrong with you? All right, so yeah, here's that feedback resistor and the 10 volt and stuff like that. Are they a nervous belcher? No, they're just like eating and drinking on stream, and it's just so rude. Everything I know about production flies in the face of their behavior. I don't know, they're just not socially they're not socialized. All right, so we're gonna disconnect the output here because we'll be testing that in a minute, and then parking the op amp that's not in use. I'm basically taking the output, connecting it to the input, the negative input feedback, and then I'm grounding the extra channel, grounding the positive input, so that this is set up as an inverting amplifier for nothing. So that'll just sit. I think that's how you're supposed to do it. Then we have our 10 volt signal going to 200 ohms with the 2 resistors. So that's all set up. This thing is all ready to go, and it's coming out of the common channel of the Max. And then I've got all of the other channels running in there, as well as plus 5 volts here, and then plus 10 volts on this one. So 5 and 10 volts I can use to calibrate everything. It's a positive input, so yes. The positive comparison input for the op amp. So 33K feedback on this one, and then this goes to ground, and then we have 100 ohms going to the common pin of the Max, and then we have 200 ohms going to plus 10 volts, sorry, minus 10 volts right here. So we go over here, and we have our audio codec. This thing is so frickin' big, and it didn't have to be. They could have narrowed this board down quite a bit. Why did they make it so wide? What are you doing here? Why is this so wide? This is ridiculous. This should be illegal. Well, anyway, the point is, I have one row of holes that I can hook up to on the outside. If I were to hook up any of this stuff, I'd have to go under the board. And I did for 5 volts, because this thing needs 5 volts for the analog reference for some reason. So this right here is 5 volts. It's big and heavy. It has to be expensive. Hold on, my patch. I have to itch my patch. I'm blocking that. Oh, sorry, I missed this other chat. I'm close to biting the bullet and buying an AC unit. Oh yeah, that's right. I need to turn it back on. I turned off chat in this scene because I wanted to just talk. That's not right. Nope, that's my glucose level. Where's chat? There it is. Okay. Yeah, home theater amps, big and heavy. Those transformers, man. And it's just about the signal coming in. I collect them because I bought them and I can't sell them. I'm really bad at selling stuff. It's actually really... It's kind of hurt me over the years. I've still got my old mixer and everything. Like, Julian was on my case about this, and I do like it when Julian gets on my case about stuff, because he will push until I actually do something. Although that does... I get annoyed very easily by that kind of stuff. So I think only Julian has the ability to do that to me, but without me getting super pissed off. But I really should sell that other mixer. And we have to get my money's worth out of the new mixer that I bought, because the new mixer that I bought does all of the complicated audio routing, so that if I ever have somebody on Discord, I can talk to them. They can hear like the soundboard, and chat can hear everything. Hate being hounded unless I really like them. Yeah, that's kind of the case. Okay, so here's the deal. We need to hook this up to I2S so that we can receive audio signals from our microcontroller. We then need to designate a couple pins, 3 pins actually, for the MAX 309, or 308 rather, so that we can switch from channel to channel. Now, in the end, in the long run, I'm going to use the port expander probably to do that, because this is a low priority digital signal. So this thing has so many pins to it that we can assign 3 of them to switch the audio input channels, probably actually 6 to switch the audio input channels, and nothing of value will be lost. Salton Sea. I've never heard of it. Yeah. I've actually never heard of that ocean. Sea? Ocean or sea? Anyway, this is a level shifter. This is what we need to use for the screen, unfortunately. Unfortunately, we need to use a level shifter for the screen. So these are all things that I'm going to hook up eventually. But for now, we are just going to kind of guess at the 3 pins that we're going to use as a digital switch. Now, let's get our inputs. So it's going to be pins 2, 3, and 4. Maybe 5? I'm not sure about that. 2, 3, 4, but in 2. The ones that we did for the other one were, it's BC clock, LR clock, and then out A, B, and C. Or rather, A, C, and D. B is on the underside of the board. So let's figure this one out. I need to get jumpers, and they need to be of an appropriate length to get from here to here, which is unfortunately in that middle ground of length where the longest one I have before they get super duper long is this one, and this one could go directly, but I'd rather have it drop down and over, which I don't think it has space for. Not really, anyway. I guess I'll use greens for that. Where are all my greens? There's over here. Speaking of audio, my turntable has decided to start spinning at slightly the wrong speed. There might be an adjustment. Oh, online says the fix isn't worth it. Better just buy a new one with better speed control. Yikes. I had a friend of mine was selling his turntables, and they were like the nice ones, like those really nice ones from the 90s. And I was considering whether or not I want to buy them, but I think he wanted like $300 for them, which is a really good price, but it's not in my purchasing ability, nor having them on a table surface. I guess I could put them upstairs in the bedroom, and then I'd look like a true music freak, which I'm not. I don't have any vinyl. Okay, I have one vinyl. You guys want to see my vinyl? You guys want to see my one vinyl? You definitely do. You definitely do. Let me get it. It's right over here. The one piece of vinyl record that I have is the Well-Tempered Synthesizer. with a bunch of 1800s dudes standing in a mirror hallway with a bunch of synthesizer equipment behind them. It's a bunch of classical music as only can be experienced by MIDI. It's horrible. It's like the worst record. I love it. Look at these guys. Look at these dorks. Ben Franklin looking ass. All right, let's get these back on the wall. That's a great album cover. That's why I kept the record. You can just tell. These weirdos are from the 70s. All right, let's put this back up there. Back over here. Are you sure it's actually MIDI? Probably not. It might be actually somebody playing a keyboard, but it's indistinguishable from MIDI because it's going through a bunch of ancient synthesizer equipment. You would be better off just opening up a MIDI file with the classical music in it. Walter the Crazy. Oh, is that who it is doing that? That's pretty funny. It was in my dad's collection of vinyls, and so I decided to pilfer it when they got rid of a whole bunch of vinyl, and I'm kind of still sore about that one because they had the White Album and everything. Like, you know, my folks like grew up around all that great music. Also wrote the entire soundtrack to the original Tron. That's pretty cool. All right. Bukuk, out, and Ulrk, and Skuk. Which do I need to actually hook up to get this thing running? I don't think I need SCK because we're not using, like this doesn't use SCK in any way, shape, or form. So we're going to use Bukuk, out, and Ulrk. So BCK goes to pin 4. Oh, the one that I had hooked. Hold on, let me get tweezers. BCK to pin 4. Next one is Oot. Oot, I take it goes to in. Is out 2, out D, into. So I guess we're going to into. Remember the tape era? I grew up in the tape era. What are you talking about? I had Thriller on tape, or whatever the one with Michael Jackson like lounging. I had the Backstreet Boys on tape, on cassette tape. Pin 5. Okay, there we go. Pin 5 for into. What this is going to end up looking like in the end, this whole circuit, it's going to be a whole bunch of these little modules on standoffs. So there's going to be a bunch of little plug-in modules, and then the main PCB for it is going to be a whole bunch of different wiring, but it's going to be a lot of circuit boards. There's going to be just a big stack of circuit boards that makes everything up. Left-right clock is pin 3. And that is our whole hookup. We only have 3 pins that we need to hook up to get I2S running. And we're not doing anything with the control of this chip, although we could. FMY, MD1, MD0, I think that's addressing stuff. Right now we're running this in master mode, so this is just going to stream audio out from itself. Oh, it's the Snoop Dogg doggy style tape. Hell yeah. I had a Whoop. There's on single. I had Whoop. There. Oh, Whoop, there it is. I think I had that too. Come to think of it. Oh my God. I just can't believe I had Backstreet Boys on cassette tape. What was your first CD? Fat of the Land. Friend of mine gave it to me for Christmas. I didn't even have a CD player. Or no, he gave it to me for my birthday. It was a great gift, but I didn't have a CD player. I had to hook a CD player up to the Macintosh. An original pressing of ELO Out of the Blue from the 70s. Nice. I don't know any of those words. I don't know who that is. I have a couple tapes mostly for the novelty of having tape. Yeah, I had a whole box of tapes that I would keep in my car because I drove an old car in high school. They did Mr. Blue Sky. That clears it up a little bit, but not entirely. I'm a weirdo with the music that I listen to. Chat overlay should be working. I don't know if something's going on with it. Or if it just went away. I don't think it did, though. No, there we go. We're good. Okay, so we've got I2S hooked up. Yeah, why isn't... Oh, it's over there. That's why. I don't see it because the O-scope is... Oh, Electric Light Orchestra. Yes, I do know Electric Light Orchestra. I do know... ELO. Okay, now I get it. Yeah, MP3 players came out. Cars didn't have auxes, and you had to use the tape thing that would break after a fixed amount of time. I got really good at fixing those, and some of them, you could just take apart all of the mechanism, all the mechanical stuff inside of them, and it would still work. They would just, because what would happen is the internals, because the tape expects to feel itself rolling a tape, right? Because they've got like anti-jam stuff in there to keep it from messing up. And then the player just had a little inducer that would press up against the magnetic sensor of the tape player, and then your audio would just go through that. But it had to have that mechanical element to it that would spin the tape so that it thought that it was feeding an actual physical piece of media. Most tape players were not smart enough to care. So what would happen eventually is that all that mechanism would gum up, and then it would think that your tape is getting stuck or caught, or it's at the end of the tape. And so it wouldn't function. So you'd pop it open, throw out all the mechanical stuff, put it all back together, and in most car stereos, you would be able to put that tape in and just play whatever you want. So it was an auxiliary input. Luckily now, though, everybody's kind of figured out doing aux inputs into stuff, and you can get little Bluetooth dongles that you plug into the aux input, and you can play whatever you want. I'm gonna burp. Okay, I burped. That would be the I2S streaming input. We don't have anything going into the I2S input. So before we actually commit any of this to code, I will physically choose a channel without the microcontroller on the Max 308, and then we can observe it coming out of the op amp here, and we can make sure that our op amp isn't going to blow up my auxiliary input. So we need to fix a channel for the Max 308, and that is done with the 3 inputs. Because it's an 8-channel thing, it needs 3 bits in order to input a number into it. So it's this pin here, and then these 2 right here. We have to set to VCC or ground. What's up, cuz? What up, cuz? So we're getting close. We're going to test stuff here. We're going to get waves wibbling around. This I2S stuff is pretty cool. We can do a lot of stuff with audio with it. But let me just ground these little gubbins right here, and that will give us our signal. I mean, I could also... Well, no, if I set it to power, then it's going to choose channel 8. And channel 8 currently has a fixed voltage level coming into it. It's not very exciting. So, let's see. Ground. Oh, actually, ground is right here. No, is that ground? That is... Yeah, that's ground. Okay, that's our ground signal. So I can actually put another jump right there. Let me see if I can find one in the trash of the desk. I can't. I can't immediately find one. All right, let's just get one out. Our car only has aux. We have a Bluetooth adapter connected to it. Mine too, but my car is from the 90s. My car is a 1999 BMW, so it has the capability to play CDs, but nobody ever really figured out the auxiliary input to CD player thing, did they? Nobody really figured that one out, how to make like a little thing that would fool a laser beam into thinking it's reading music. I had a 99 BMW, great look. I'm not super happy with the look of the 99s because of what's called the jelly bean era of cars, when everything got kind of fat. Cars kind of let themselves go and had too many jelly donuts. I can relate, but they all got kind of fat during that era because aerodynamics, and then suddenly car companies discovered, you know what, squares look cool too, and they started having some really much more complicated and interesting designs. But the stuff before that in the 80s, where everything was nice and angly, that was nice. What happened to your Volvo? You guys should know that Disco House Days' dad still drives the same Volvo from the 80s, and it's amazing. It's completely covered in rust, but it still works. My Volvo was the Volvo 164, We ended up donating that car, believe it or not, and that was somewhere out of high school. But the Volvo 164 was a really neat one because it's a Volvo 240 that has a luxury front end put on it. So it actually, from the firewall forward, it has an inline 6-cylinder iron engine that's like super duper resilient. And then all of the bolts and stuff are English instead of metric. So me, a teenager without even my own toolkit, getting this car because my brother like hounded my parents to get me this cool classic car, getting waves from people, trying to fix it, and then having to immediately buy a full toolkit of English and metric all at once. It was ridiculous. Did you know the skirt of a mushroom is called a vulva? I didn't want to know that, but now I do. What do we do with this information? How do we move forward from here? 80s was peak BMW. The older, like early 90s and 80s BMWs, I would love to have one. Just that blocky sort of design is just a wonderful thing. All right, so we're set up to receive channel 1, which is going to be, I think, this one, which is going to be this one, which corresponds to, I think, the second channel here. So it'll be a sine or a triangle wave. Let's fire this thing up and see what we get right here on the amp that faces the, what do you call it? On the amplifier that faces the audio input. Jeez, that was a, hello brain, how are you doing today? My brain doesn't have a mushroom for that information. You guys are so funny, chat. You're so funny. Funny. That's what you guys are. Okay, my local Ace had a full socket set, 300 pieces. I got some like sharper image socket set, but still, the best one that I bought, and I wish I bought a larger set of these, are the one that I still use. It's a Craftsman set from the mid 2000s. The Craftsman set from the mid 2000s with the like gold boxed labeling. This thing, I still think is one of the best. The tools are a little bit blocky. They're a little bit blocky, but I don't mind that. I know the snap-ons are pretty popular because they're pretty rounded and it doesn't hurt your hand, but I'm not a mechanic. I'm not using these things 24 hours a day, so I like the look of these. And we've broken these apart on stream before in order to refresh them. The miniature, this one, the miniature ratchet, wouldn't click over properly because the grease in it had like hardened in weird ways. So what we did is we took this thing apart. It's just a snap ring on the thing. So we took it apart, cleaned it off comprehensively, really dug out the hardened grease, and then I put my own red grease on this. It's the grease that I make myself. It comes from my body. No, it's just red grease that I bought. We put that in there, and never looking back. This thing is amazing. It just clicks perfectly. This is not the Craftsman set. I meant to show that. This I bought because these are deep sockets, but the one that came with the set are a bunch of little short ones, but they've got like really nice labels on them and stuff. From this era, these are like quality tools. And I hope I never have to buy it again. If I do, maybe I'm going on eBay and looking for this set, but I should have bought the super duper set of these, and I didn't do that. I'm kicking myself about that. Everything is now penny pinched down to like its final breath. So I don't know what they're like, the modern ones. But this was back when Sears honored the lifetime warranty, and we would use any tool as a pry bar. So if the tool broke while being utilized as a pry bar or hammer, we would just show up with the broken tool and go, please, sir, can you fix him? And then they would just go get another one off the shelf, and you'd go and get one, and then we'd giggle the entire way back to the car. They don't do that anymore, unfortunately. Yeah, died to self-deletion. Yeah, rest in peace, Sears. It was always nice to be, 1 minute of the afternoon you're jumping on a pry bar, and then the next minute you're showing up at Sears with a broken friend. They do that with the Huskies? Oh man. Yeah, they're super duper good tools. Okay, let's my dad will never let me forget I lost a set of Craftsman wrenches. Because they're good wrenches. Okay, so we're gonna plug this thing in. This is gonna start streaming I2S. It'll be getting back I2S, but it's not gonna do anything with it. We haven't assigned those pins yet. So it's gonna stream I2S to these 3 devices. These are gonna create nice clean waves. Those nice clean coal. These nice clean waves are going to go into our amplifier section where they will be boosted all the way up to plus minus 10 volts. That boosted signal will then go into the Max 308 where we have selected for pin 1 to be connected to the common pin, which runs back and into this amplifier, which is going to tamp down that plus minus 10 volt signal and shift it on the number line so that it is 0 to 3 volts. So what we're going to see back, and my finger is cramping because my glucose level is dropping. I get very Charlie Horsey kind of crampy when my glucose level drops. So like pointing at this thing, my muscles like, and I'm like, no, stop it. Anyway, we're going to see that output there. We can actually observe the input as well. So let me put the input here. I think it's going to be this channel. And then we'll see on the yellow line, we'll see a 0 to 3 volt signal. On the blue line, we will see a 0 or a plus minus 3 volt signal. Charlie Horse is a funny word. Never met him. And this is all being streamed through my brand new amazing Rigol oscilloscope. Rigol did not pay me a red cent for this fucking scope. I paid for this. This is my milestone birthday gift, and it was not cheap. Why do I hear knocking? I hear knocking and barking. One sec. One sec here. Okay, before we move on, I need to move my car really quickly. So I'm going to put on music, and I'll be back in just a second. So let me put that on and put a setup, overlay, BRB. I'll be right back. I just got to move my car. Is that actually playing? Oh, wait. I got to move my car. I'll be right back. We are listening to the Space Cowboys 8-ball Don't Stop the Yacht Rock. It's an old mix. It's like 10 years old, but it's yacht rock. So it's all those soft rock hits, ironically. Pause. Okay, so that's what the mix is. Now you can only hear that on Twitch. You can't hear that on YouTube. I've gotten a visual copyright strike though. Yeah, that's right. That's right. I introduced you to those guys. When I went to Burning Man in 2011, one of the fellows we were there with, Scotty, was like, "Hey, just look on the horizon and see if you see orange in the deep playa." And we're like, all right. So we start biking out there, and we're biking out the deep playa. So it's all just flat, complete acrid desert. And we see just an orange glow, what looked like over the horizon, but it really wasn't. It was just in the distance. And we biked all the way up to it, and it was the Space Cowboys. And what they did, or what they have, is a Moog, not a Moog, a Unimog. They have a Unimog that they've modified in order to be just a pop-up DJ setup. So they had like a pop-up DJ setup, they had like a bar setup, and everybody was just partying to deep house. Okay, so deep and disco house, actually, to be clear. But from then on, I was just like, all right, these are like easy to find mixes that just have like semi-pop, just kind of house vibes. So that's what I'd been. I listened to them for a while, and then I kind of broke away from that and listened to a bunch of other stuff in an interim. But like Twitch has bumped me out of using copyrighted music. We're back now because I don't have it on the VODs anymore. So, okay. I had to move my car real quick. They were doing tree work in the neighborhood. So basically I had to release the parking brake and let my car roll into a parking spot. Okay, so here we are. It is nasty out there, by the way. It's super duper warm. We've got all of our stuff hooked up, and we're ready to test to see if our audio signal coming through most of the loop is going to be too loud for this analog sensor. It may go to 3.3 volts instead of just 3, in which case we will have to do something about that. We'll have to tamp it down just a little bit in order to get it to fit within 3 volts. But we've got most of what we need in order to test this thing properly. Now, positive 10 volts is good because it's going through an inverting amplifier. So actually it gets inverted and then reverted. So positive, positive 3 volts is going to become negative 3 volts. And then it's going to become positive something or other volts. Jeez, it's going to be really weird. Let's just turn it on and see what happens, though. So that would be the power supply all the way over there. And I turn it on, and we get 12 volts in here. And that's not all. 12 volts doesn't quite do it. It doesn't power up the microcontrollers. Then I power up the micro. That gives us 3 volts out to everybody. These should be lighting up. Whoa, okay, we got a short. What's shorting out? What happened? Uh-oh, why are you shorting out? Ground and 3 volts going to V in, and then is that ground? That is ground. Why are you heating up? We may or may not have just blown up our whole setup. This is why we breadboard. All right, let's take a look. Oh, that didn't necessarily turn it off either. I need to unplug it to turn it off. Who's blowing up? You're blowing up. Why are you blowing up? My MCP 6002 is the one that's actually getting hot. Is that right? Yep, that is what's getting hot. Specifically the microcontroller, right? Or no, the op amp. Yeah, specifically the op amp is getting hot. So what did I hook up wrong? Let's double check over here. Oh. Yeah, that might not be right. Oh, I hooked it up to positive and negative. Whoopsie daisy. Right. So we just cranked this thing up to 12 volts, which we were not supposed to do. This is not supposed to go to 12 volts. So we're pulling this. This is supposed to go to 3 volts. That was dumb. Well, that thing is permanently damaged, and I'll have to get it out of here. I hooked this thing up to plus minus 12 volts. That's a big mistake. Again, this is why we This is why we hook this thing up sequentially and test it out that way. I almost jokingly said I hope it doesn't explode. I hope it does explode, because if something explodes on here and it's a genuinely natural reaction, that could go viral. Because y'all can clip that stuff and share it with your friends, all 70,000 of your friends. We don't have exciting moments like that too much, because I don't want to force it, because when you force the oh my God reaction, it shows. It really, really shows. This is a TLS-7 III, or 2 rather. Almost died, but it became viral. I mean, yeah. Yeah, that's the sad reality of the internet. The sad, sordid state of affairs. That's what you get. That's what I signed up for. MCP 6002. Somehow, I believe I am running out of them. I had a bunch in here. I don't know where they went. I don't think they're in their own chamber. I think they're in here with the TLS-7 IIs. So we need to rifle through some of these and see which ones are the chip that we're looking for. Because some of these are TLS-7 IIs. Oh, you know what the MCPs are? They were a little bit more expensive. They're on their own thing. They're on this right here. There we go. Oh, that guy got in a shitload of trouble. I don't see how you would not consider that you would get in trouble for that, but and it was very clear to see how fake it was. It was not that difficult to determine that he was being, seeking attention by jumping out of his own airplane when there was nothing discernibly wrong with it. Nothing. Yeah, he was like, oh, I just happened to set up a camera here. Oh no, something's gone wrong. Better jump out. Yeah, the FAA really got into him there. They sunk their teeth into that one. Give chat control of your bench supply. I'm sure something will happen. I'm not great at vetting out ideas, so I think you have a good point. MCP 6002 is a ground to 3 volt device. So hooking it up to ground or negative and positive 12 volts wasn't a good idea. The ones that drive me nuts recently are ones where it's a video that clips back to the one guy with no reaction on his face. They're like that test, that film test that they did where you can infer, you can imply mood from like a video image. If you clip back to somebody who's making no reaction and you clip the food, people will think, oh, he's hungry. That test. MCP 6002, we have VDD and VSS. So pin 4 is VSS. That's going to go to ground in this case. And ground is here. So we take this pin and it goes here instead with its buddy over there that also goes to ground. I could probably just use a 1-to-1 jumper over there. And then over here, we do not go to 12 volts, we go to 3. 3 volts is being created externally. I guess I can go to the other side of this hookup and run a wire horizontally over to this. We'll just put a green wire, I suppose. One of the greens. And that'll be our 3 volts. We're not using the microcontroller's 3 volts because it doesn't seem to have enough power. It was heating up and the audio outputs weren't working. And these are all the things that we got to test in a system like this. So that's a 3 volt wire. And we're going to power. Yeah. Things are getting fractally more complicated in this setup. Oh, wait a sec. Hold on a second. Oh yeah, no, that one does go to ground because that's the positive. This is the positive input. This one is the 3 volt input. Everybody already knew that. That's not a new fact in any way, shape, or form. Everybody knows that already. At least I know that because I've messed around with night vision stuff for a long time. Okay, so then our observation is on the output of that op amp, and this right here is where we're going to plug in. That random, not new or fun. Well, it's not your job. Do your job. Okay, do this. Scope's up on screen. Chat presumably is up on screen. It should still work. Yeah, there they are. They're behind the scope. And so now if I turn this on, it shouldn't explode. It should just turn on. We've got red lights for good on that, so we're not shorting out our 3 volts. I've got 12 volts on the thingamajig, 12 volts on the power supply at 0.02 amp, which at 20 milliamps is about right for this much electronics. That is a lot, but for something like this, but it's what it's. And then we plug in so we get the signal output. And there is our signal, and it's cooked. It is a little bit cooked. Why is my trigger not working? Okay, so that's our 0 to 3 volt input, and that's our 0 to 3.3 volt output. And it looks like it does get fully to 3.3, but it is also maxing out, both positive and negative. So the 33K resistor is not appropriate. So we need to find, first off, a 50 kilo ohm should probably be enough, although if I go up to 100, that means that I can take it all the way down to unity. I don't want to take it down to unity. I don't want the ability to take it down to unity. So if I put in a 50K pot, this one here, we should be able to adjust it down. And this is, again, I got the question yesterday, why aren't you using fixed resistors in the op amps? And it's because it's going to need adjustment. I'm going to need to be able to tweak everything on this because it's a piece of equipment. Yeah, unity gain is when you 1-to-1 ratio. But you get to say unity gain and sound smarter. It's all about sounding smarter. Does that mean it's, I think it means it's this one. 503, yeah, 50K. So in order to get this into the op amp, I can either jumper it far away or I can bend one pin up and out of the way. Let's do to this pin. Well, we have them all facing the same direction. So we'll do it to this pin and I'll bend it up and out of the way. And then this plugs in down here. I'm going to have to make room for it. So we turn everything off, turn everything off. So there's not quite ample room for me to plug a potentiometer in because these 2 wires are going to interfere with the pot's body. I could sneak it up there, and I guess if I move that resistor down. Okay, so let's move, this resistor goes up. This is how I make the 200K ohm resistors. I double up on the 100 kilo ohms. Let's get that out of there for right now. This I'm going to move down and out of the way. And then this I'm going to move up and into the way because it will interfere with the potentiometer less. Might just be easier to jump this to a clear area. Come on. These tweezers aren't very good at gripping through whole parts. You know there's something about you. That song's going to be stuck in my head. Even though I don't know all the lyrics, and I should. I used to listen to that stuff on the drive to school with my mommy. There we go. So now we have an adjustable potentiometer. So now the ratio of the 100 kilo ohm resistor to the 33 kilo ohm resistor can be adjusted. And since this is only powered by 0 to 3.3 volts, it's not able to saturate and blow up our I2S audio input. This is the only one of these I have. I'd have to buy another one if it broke, so. Adjusting by physically replacing resistors sounds terrible. Yeah, and like with heat and stuff, I wonder if this is gonna drift. But either way, having the instrumentation potentiometers in there it'll be nice because you can kind of adjust ratios and get everything kind of humming to the right tune. All right, Vilps, thanks for stopping by. Vipels, Vilps, Yipples? No. Yilples. My mouth hurts trying to say your screen name. So let's go. I always thought the Let's Go in Super Mario 64 was Nitpickle. It sounds like he's saying Nitpickle. I'm not the only one who heard that too. There are other people who hear that. Why do you? Oh, because we're not observing it. It's in a superposition. Why does that look worse? Oh, because the pot is not adjusted. And there's something about you. Let's take both of these channels and zoom in on them. So that's there, okay. So it just shifts it on the number line. Now the signal that's coming into that should be stable. Let's check our input signal here. Where are you coming from? You're coming from here. Yeah, that's not clipping in any way. Nope, not clipping. And we are at full spread plus minus 10 volts. Beautiful signal. Beautiful. Oh, Latin for voltbase. Ah, I suspected as much. I can say that after the fact and nobody will believe me, so. What is getting so hot? That's the microcontroller. Yeah, this thing just runs a little warm. It's not prohibitively hot. This thing is. This thing will get, like, burn you hot. Holy shit, that thing's making a lot of heat. We might be at the upper limits of the amount of 3 volts that this thing should be able to operate up to an amp, though. And I don't think we're drawing an amp. So there's that signal, and then coming out of this... Oh, we're already looking at it coming out of this. So let me just go to that channel there. Certainly not that signal. Okay. And then we need to shift that up. Why is it not moving? I guess it is. It's just subtle. These are 25 turn pots, so, and we need to get up to the upper limit of what this one can get to. Yeah, 3 volts is parked right there, so I don't know if maybe I need a slightly different resistor on it so that it doesn't clip. Yeah, we actually need, I need a bigger value. Turn that off. That should turn that off. So let me go to 100K, I guess. I think we might need 60 kilo ohms. I think that's what I had on one of the other ones. So if I put in, well, we don't have any 100Ks. So I'll put in a 200. And we'll just see if that works out. But I'll have to. I need to buy a bunch of potentiometers, I guess. Another one of these kits. Oh boy, that pork roll gonna give me super duper heartburn. Am I gonna get super omega heartburn? So plop that guy in there, and then we go back to this view, and then we turn power back on. That's getting a little closer. Here's my problem, is that waveform is too big. Do I need to put a larger input resistor on it? I think that might be what needs to happen here. Because, like, I can center it, but that doesn't really help me that much. Look at that. And we're definitely getting 3 volts into the thingy-wingy. Well, that's 3 point, what's the max on there? I can't read that. Yeah, 3.5 volts. And there it goes from from 0 to 3.6. So 100K, I guess I can try throwing in like, well, let me just put, oh, well, we're out of 100K, so I'll put a 200 kilo ohm resistor on that line on the input, and maybe I can tamp that down just a little bit. Why wouldn't it be? So it has the the negative 10 voltage source coming in off of a 200 kilo ohm resistor here. Oh, what's going on there? Whoa. Why is that lumpy? Something to do with how the current's being drawn? By the waves? See, there's negative 10, but when it gets to the pot, or to the amp, that's positive 3 volts. Negative 10 through the resistors becomes something else. Well, I guess it's meeting up with the with this. So now what's going on? Where else is my negative 10 going? It's also going here, but this is a different, yeah, this should just be, yeah, that's just, it just goes away. Okay. Okay, so input resistor. See, we're starting to meet up with the limitations of the system here. That pin right there is not doing anything. So what I'm going to do is I'm going to put the pot right here. I'm just going to put this right here, and then I will jump over to it, bypassing this 100K resistor. That just kind of opens the field up a little bit. It keeps things from running into each other. Let me unplug this. This is getting in the way of everyone. Just get the hell out of here. We're not ready for you yet. All right, so get this out of here. You get out of my way. Out of my way. Oh, wait a minute. What was I? What the? Get this out of here. What? No wonder. Hold on a minute. Wait a second. Back it up. Back up the truck. Hold on a second. I had both resistors in there at once. I didn't get rid of the old resistor in lieu of the potentiometer. No wonder the adjustment was all weird. Let me try putting the what do you call it? Putting the pot back, the 50K back. See what that does. Where'd it go? What did I do with it? Did I put it away properly? Yeah, I did. It's right here. So let's try 50K in there, and actually without the other resistor in parallel. That was having the amount of resistance on the thing, so I probably adjusted it to max, and then it wasn't doing anything. So this one goes back to here on the output. And this thing is feeding back on the right pins. Yeah, it's feeding back there. These are all plugged in there. And then this goes to output. And eventually that output's going to go to our DAC. But for now, that's all hooked up. Yes? Okay. Turn that back on. Okay, so now we're even more clippy than we were before. And I don't know if this will adjust what we want it to. I think this will just shift it on the number line. We actually want it to tamp down. Man, I think it's working. Is it? No, see, it's not shifting it up. I need it to shift up, or the overall wave needs to get smaller. I don't know why it's only moving in that direction because of the 10 volt offset that's being put into it. If you pass too much current through a variable resistor, are you a pot smoker? You could also be a rheostat smoker. Ha 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 ha. Okay. The question is, how do I get this to properly represent? Because right now we are in good synthesizer voltages. We're not getting our synthesizer voltages in here for our plus minus 10 volt signal. It is flipping it over the number line because we're adding a negative 10 volt source to the whole thing. But we need either to turn down the feedback and then turn down. So let's put a 200K. We need a couple of adjustments here to get this super duper right. I need a 200 kilo ohm. Actually, no, more than 200 kilo ohms. I need all we have is a jump to 500 kilo ohms. So we will have the ability to super duper bias this thing with a 500 kilo ohm. Since right now it's set at 200K, we need adjustment around that. So we'll put this on the negative 10 volt source. And then we will replace that 100 kilo ohm input with our own thing. Let's just do this one first and see if it's maybe this is the only one we need to adjust. We're biasing this line right here. So this and this go away. And then we put this guy here. Oh my goodness, the dog is going psycho because they're mowing the lawn outside. So there's our 10 volt going into there, and we're going to take this, and that goes over to the input. Just take one of these. Oh, that's too short. We need slightly longer than that. What do we got? What do we got? I got all kinds of stuff. I got what you need. You know there's something about you. I never thought that music would be hip. The soft rock hits of yesteryear. I'm totally fine with it being hip though, because I know all of that music very well. Okay, so now we can adjust a 500 kilo ohm pot that will affect the offset bias. So we can lower the amplification of the signal and we can move the waveform on the number line. Theoretically, let's just see if that is actually the case. Man, I need to buy one of those potentiometer adjusting tools if I'm going to be dealing with these instrumentation amplifiers more. Okay, so we're back in the same boat that we were, but I think what I can do now is I can lower this thing down and then affect the offset more or less, maybe. It's weird though that it shifts like that. What is this doing? I see something happening, but I'm not quite sure. I'm not even screwing the thing. God, these are annoying. It's very hard to keep your tool on these. What the heck? Code Rush raiding with a party of 19. Table for 19. How you doing, Code Rush? Oh, this is clicking. We're at the limit. How you guys doing? What's the difference between a potentiometer and a rheostat? A rheostat is a wire-wound device, I guess. So I guess what you're doing is you're feeding your current into a wire-wound thing, which is a little bit more, I guess, stout than a potentiometer. Doing well? It's cool. We haven't gotten into the coding part of this project yet, but this is going to be a comprehensive coding project. Right now we're working on the Loop, and the Loop is an I2S audio engine. So this is a Teensy 4.0, which is an incredibly powerful microcontroller we're discovering, and it does audio stuff really easily. The thing about this is the audio stuff that it does, it will allow me to build a modular synthesizer testing module. So the module will be able to test itself and other modules in order to perform tasks. And that way I can fix Dave's M303 that's been broken for God knows how long, and I haven't been able to fix it. It's an analog synthesizer, an analog VCO, and it's broken. And I've not been able to create all of the signals that are required to test a module. Now, I could leave this thing like this, but I'd rather eventually build it into its own modular synthesizer module. And it turns out that we are really going to be doing quite a bit of work to get this thing off of the ground. Right now, what we have is the Teensy 4.0 streaming waveforms via I2S out of 6 individual channels. And these channels are all producing unique waves. Where's my probe? So we have a triangle wave. We have a sine wave. We have a sine wave. We have a reverse sawtooth. We have a square wave. We have a regular saw. Where's the regular sawtooth? Maybe that's what the sine wave is supposed to be. I think that's what this one's supposed to be. Anyway, the point is we got 6 unique channels coming out of this thing. Pretty cool. That's pretty awesome for something that's outputting like, you know, nice waveforms. That then goes into a stage of amplification. So we have a bunch of op amps that I put adjustable potentiometers on, and we adjusted them all so that they are plus minus 10 volts. So if I test them over here, I get a signal that is plus minus 10 volts. Now, I'd have to adjust the scope to really display that, but everything seems to be chooching away very nicely. Everything's working perfectly. We put it into what's called a mux, and the mux is essentially a solid-state switch. And so now we can address each channel on that thing and assign each channel to one singular output. And that one singular output then has another amplification stage that damps down the signal and puts it out to an I2S digital to analog, analog to digital converter that will then translate that waveform back into our microcontroller. Now, we haven't set up anything from that amplification stage. We're looking at that right now to make sure that I don't blow up my nice analog to digital converter. The A to D can only handle 3 volts. Since we have an op amp that is only operating off of ground to 3 volts, we can't blow it up. But what we can't do right now is fully express that signal going in. It shouldn't be clipped. It should not be clipped. It should be shifted on the number line, and it should not be clipped at all. But it is. I also don't know why there's like a weird delay on that. That's strange. So yeah, what we're doing right now is we're trying to adjust this so that it is within specifications. So what I've done is I've added potentiometers on various pieces of the setup here. Right now, what's happening is we have this plus minus 10 volt signal coming in. It goes into a differential amplifier. And what the differential amplifier is doing is it is looking at the voltage level and comparing, basically the resistors that it have operate a feedback loop within the amplifier that's able to either amplify or tamp down a signal. So we're tamping it down. We've got a ratio of 1 to 3. Which actually, I think maybe what's affecting, well, we're using mutable instrument circuits because Emily Gillette uses a lot of 3-volt microcontrollers. And so looking through their schematics, which I don't have open anymore. No, I still have Edges open. Like Edges, this is an Atmega 324. This is a 3-volt microcontroller. So if you're getting a control signal from a plus minus 10 volt signal, you need to tamp it down. And so what happens is you have an AREF minus 10 coming in here, and it's biased 200 to 100 for your control voltages. And then this is just an adjustment, but these voltages mix here. So what happens is negative 10 is applied to this line with a bias of 1 to 2, I think. But the purpose of that is that if you have a plus minus voltage signal and you add that big minus signal, it's going to shift it downwards. And because the amplifier is set up going into the negative input, you have an inverting amplifier. And so that inverts it and puts it to the positive part of the number line. So if you have that signal fully shifted down, now it can be negated, it can be negative can be applied to it, and it will always be positive. It's just the little weird things that we do with these amplifiers. But 100 to 24.9. Now I had a 33K in there, and that was maxing out. So maybe if we adjust this now, it would actually work out properly. The only problem we're having, though, is that things aren't quite happening correctly. Well, also when I touch the board, everything goes janky. What's going on with that? Why are you getting so weird on me, bud? Strange. We got a lot of signals floating around this thing, so it's you know, there's some weirdness going on. Not to mention the fact that I'm wearing a phantom-powered microphone. Okay, so adjustment-wise, this thing we should be able to get into adjustment and get the appropriate levels out of, but I mean, we can take it over here into saturation, and I think if I keep going in this direction, well, it should be shifted properly on that number line. I don't know why it isn't. So if I keep taking this down, those negatives should be reducing, and it doesn't look like they are. Whoa, that's the trigger of the scope. There we go. So if I bias the 10 volt input I just don't get why this is happening the way it is, because these mutable instrument circuits have been pretty perfect. Oh, that's at 0. So let's increase the resistance to the 10-volt input and see if nothing appears to be shifting from that. Because I thought you would bias them based on... Oh, it does appear to actually be moving. Wait a minute. There we go. So we want our VPP to be 3 volts. Our VPP is 2.2, and our maximum is 2 point something as well. Now we can work with that, but I want to utilize that full range of voltages. Now the VPP, every time I say it, the VPP that this thing likes, it likes a certain kind of PP, and it's the 3-volt variety. So we're going to take that to 3 volts using the adjustments. And while we could observe those resistance values and put in fixed resistors, I'll probably leave these to potentiometers in the end, just because I will then be able to go back and adjust for stuff. So let's get our PP to 3. 2.7, 2.8, 2.9, which is pretty much 3. So there's about 3 volts PP. And now we can adjust it onto the number line so that it doesn't violate anything by shifting it with the 10-volt bias. So there it is. Look at that. Beautiful, beautiful signal. It's not even inverted from the original wave. Although when we get control voltages in, it will be inverted. So if we're going to give statistics, any particular, numbers about this, we're going to have to invert it. Like if we're giving like a VPP, and that's not really going to matter if it's a wave. But if it's like a control signal coming in at different values, if we're adjusting like a 1V per octave signal, we're going to want to shift it back into the 0 to 10 volt number line instead of the negative 0 to 10, because it's only got one stage of inverter. Although technically I could put it through a unity gain. Oh no, but we're going to use both of the amps off of this thing. Then again, I could have put in a MCP 6004 and I could put it into a unity gain amplifier, and then it would spit out the proper voltages. Maybe I'll do that. Let's note that down. Write that down. Anyway, this is the kind of stuff we're working on here, Code Rush. We're not doing anything too crazy. I'm not building a flashlight that can render my retina into little crispy hot dogs. I'm not trying to blow up my entire house, that kind of stuff. There's another Twitch stream where the guy does super crazy stuff all the time, and I'm kind of jealous of it. He's got a much bigger audience. We're doing real work here, I say, as my tone of voice gives way to regret. Oh, no mayhem. Yeah, no mayhem. No mayhem. Not today, anyway. Sometimes mayhem, though. We almost blew stuff up. We almost blew up a circuit. So what I'm going to do here is just do one of these guys with no resistors on it. And that means the bias is 1-to-1. While it could be considered a buffer, in this case, moreover, it is just simply an inverter on the input, so that when I read a voltage, it's that voltage. We're not going to put it into the circuit here. Actually, yeah, let's put it into the circuit here. Let's do that. Wow, that is a really janky... This is my notes page. You always have a notes page for something you're building like this. And because I'm building it off the cuff, as in just, we've built a lot of stuff like this on this stream. We do a lot of stuff like this, like, building a cool circuit that's going to power a bunch of different stuff. When something comes together organically like this, especially on the breadboard, you want to have pages of notes. And I'm doing them in Paint. I do it in Paint because it's much more easy for me to just sort of free draw stuff on there. If I had a bit more desk space, I might even use the drawing tablet to do this because it's fun to be able to draw whatever the hell I want. I've gotten good at mouse drawing, though. I mean, I'm pretty good at that. So we just kind of stick with that sort of thing. But yeah, this is where I take all the notes on what is in the circuit and different pins that we're using and stuff like that. Explained in Paint. MS Paint! Eventually, we're going to have MIDI in, which is going to be kind of crazy. MIDI in, we're going to have all kinds of ins and outs on this thing. So yeah, we're hooking up to this part of the circuit. This part of the circuit's also going to have a little transistor thing on it that will allow us to get gate signals accurately, because we can only observe audio on 2 channels at once. So that's all we're able to do. Now, if we put in a whole codec chip, we could actually get 8 in, 8 out. I'm not sure what resolution we get. Probably wouldn't need all that much. There's a teensy project that explains all of that, but I don't want to do 8 in and 8 out, and these are parts that I have. I actually bought the D to A and the A to D thinking that I would be able to power a tiny FPGA via phantom power and have that as my microphone filter, because I could do some really nice like compressing and filtering that way. That never came about because I think phantom power barely creates any power at all. It can barely handle the singular op amp, actually dual op amp that I have powering it right now, powering my audio right now. So one day we'll go back to microphone-y kind of projects. Okay, so now that we've got the appropriate voltage level out of this thing, oh yeah, we're gonna set up a unity gain amplifier, which we already have. Is this your card? So this one's already set up to be unity gain. What we'll do is I'll take the output here and I will plug it into, this would be the, pin 1 is the output, and then this one is the input. So all I need to do is loop a wire. I could go over the IC. I don't like going over the IC. I like going around. Although in this case, well, it's going to be exceedingly difficult to do. So this is the output here. And that's going to go to the input here. Without blowing everybody up. And then that should be nothing. Good day to you, sir. There we go. Wait, why is that clipping again? Huh? What the? It also should be inverted and it's not. What am I missing here? MCP 6004, this one, pin 8 VDD, pin 1 is output, pin 2 is minus, and we're shorting those two together. Pin 3 is positive, and we're just doing a simple inverting amplifier at unity gain. Why then, if I'm just coming in here with nothing and I've got unity feedback, do I need to put 100 kilo ohm? I shouldn't need to do that, and it should invert the signal, but it's not. Pins 1, 2, and 3. Pins 1 and 2 are shorted. Pin 3, there's, what the I don't know why it's doing this. Well, now there's nothing. Now you get nothing. Do I need to have the resistors on there? Maybe if we put 100K and 100K on it, it'll then properly invert. Oh, now we're not getting nothing. Well, let me power this off before I short everybody out. I guess maybe it's unable to fight its own signal. But by all means, that should have worked. Let's just get a couple 100Ks here. I ran into some earlier. It should be easy to find. Let's get this short out of here. Yeah. And then get this guy. I know this one's a 100K. So I'll take that and I'll bend it down and then clip off the leads. And we can jump over those 2 pins. And we'll have 100 kilo ohms on the feedback resistor. Just like so. Bim. Head short. And now I need 100K to go from output. That's going to be kind of sloppy, isn't it? 100K from output to input. Now I know these are 100s, so I'll jump from input. So this is where the input is going to be over here. And then our output goes on the scope. And so I can take this pin, the output pin, and go over to here, which is, it's getting a little messy, but this is kind of what we signed up for. So feedback, yeah, to output, which is not pin 8. Pin 8 is the power pin. We're pin 7, and we don't want to short it out with its buddy right there. Like that. So there's our 100K that goes to a feedback resistor of 100K and then to our output. And so that should invert our signal. Maybe too much current on the other one or something. So now what happens if I turn it on? Boop. Everything explodes. Cool. Nothing. Just what I wanted. What the heck, man? We're still, power's plugged in. We've got 100 milliamps running through our veins. There's our signal. There's our signal. There's our signal. You get nothing. Good day to you, sir. Is this thing broken? Is the op amp broken? There's our input. 1.4 volts. There's nothing coming out of pin 1. No, this thing is brand new. This thing isn't broken. We are on ground. We are on 3v3. Yeah, there's 3v3. But our signal's nothing? Why am I striking out with this op amp? Why? Wait a minute. As soon as I go off script, everything gets jumbled. What is this pin? Is that one definitely ground? Yes. Definitely ground. That one is ground, and the thing is grounded properly. For some reason, this just doesn't produce output. Those are connected, right? Yeah, we got plenty of signal. Plenty of signal. An output over there is 0 to 3 volts. It's just, I guess 100K and 100K is, that should be unity gain. That should actually not. What the fuck? Why am I so confused, chat? Help me. I don't know why I'm so messed up about this. Here, look. We look up op amp circuit. Op amp circuits. So the top 10 op amp circuits, we've got pretty standard forms for these things. The voltage follower. The most basic circuit is the voltage buffer. It does not require any external components, as the voltage output is equal to the voltage input. Students might become puzzled and wondered whether this kind of circuit has any practical application. Well, in our case, it does, because we're trying to flip our signal, but Vs is equal to Ve. So voltage in, voltage out, inverted, which was not happening for us. I don't know why that wasn't happening. This circuit allows for the creation of very high impedance input and low impedance output. This is useful to interface logic levels between two components when a power supply is based on a voltage divider, blah, 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 blah. So if we want to bias, we can use this. We're not. Inverting op amps. So this is the workhorse of all the stuff that we're doing right now. Vs is equal to negative Ve R2 over R1. Oh, that's okay. So there's no inverting here. Vs is equal to Ve. I see now. But R2 and R1 we set at 100K. So 100K over 100K. Now there's going to be little differences in there, so it'll either amplify a tiny bit or dampen a tiny bit. But Vs is equal to negative Ve because we're 1 over 1, which is equal to 1, which is multiplied by Ve does nothing. So the ratio of R2 to R1 should be our voltage output. Why do we get nothing? Why am nothing? Why am nothing? We are referenced to ground, and I'm looking at the output, and we do have an input signal. There it is. Look at him. He's adorable. But I get 0. 0 output. Check all the way up at the pin. Nothing. Next pin down. There's our little guy. And this is ground, so we get nothing there. Well, I'm confused. I am confused. Here's our input. We got a nice 3 volt, ground to 3 volt signal. Oh, but wait, this is ground to 3 volts. Well, yeah, no, I do want it to be inverted. Are the resistors good? I mean, I'll check them. Never rule out the dumb stuff. Or rather, rule out the dumb stuff. No, do rule out the dumb stuff. That's what I meant to say. Go to ohms and let's check. Let's double check our resistors. You guys can't even see the meter. It's right there. $99.8. 100.9. So yeah, they're fine. The breadboard's filling up nicely. This is the only area that I have left. I guess I'm going to do the digital stuff up here. But right now what we have going is 3 channels of I2S coming out the Teensy, going to the 6 channels of audio via 3 I2S devices. I2S channel C, it's A, D, and A, C, and D are what I'm using right now. Channel B comes from under the board, so I'm not using it. That comes out here, and that's where we're observing this audio signal. It's a plus minus 3 volts, so 6 volt peak to peak, which is pretty hot. But that goes into our amplification stage that we worked on last stream, and that takes it to plus minus 10 volts. That plus minus 10 volts is then applied to the MUX, the MAX 308, where we can select any of the 8 channels. So it's 6 audio channels and 2 voltage references. One of them is -10. I set the other one to be 5 volts because we needed 5 volts as an enable for this thing. That way we have voltage references that we can drop in on and actually calibrate the whole system. It'll be kind of cool. So anyway, we've got that. Then that outputs to an MCP 6002, which is running 0 to 3.3 volts. And so that tamps down our audio signal, puts it on the positive number line, which is not really necessary, but it does it anyway, and then applies it to the DAC, which can only handle a peak to peak of 3 volts. The problems we're having, first of all, is that I had to shift the signal on the number line to get it to stay in the positive voltage level. I mean, I guess I could, thinking about it, I don't need this to be on the positive number line, is it? Is the op amp using an open collector? If so, you still need to pull up on the output. Let me check that. I mean, we didn't have any problems outputting to nothing on, like if I unhook this and I put the multimeter on it, it'll still read. So no, I don't think it is. I don't think it is open collector. We'll check. Let me check with the data sheet. Yeah, you can answer. Go ahead. I'll be nice because I'm in a rut right now. I can't figure this out, so I don't need to know spoilers. You're building an op amp to invert a 0 to 3 volt signal, and it's trying to, but it would have to produce -3 volts to 0, but its rails are only 0 to 3.3, so it can't do that. You would have to apply 1.65 volt at the plus VE to make it work how you want. Ah, yes. Okay, yes. That's funny though that it takes the 0, I guess the -10 is shifting it into negatives, and then it's expressing a positive number. And I'm thinking about it. So if I go into the inverting op amp first, then I go into the scaling op amp. Thank you, Ben Gizmo. That is, you are correct, and I didn't think about it in those terms. You are correct. So what I'll do is I'll invert it first. Wait, no, but then it still won't invert because it's still 0 to 3.3. So I would have to use a TLO72. I guess that explains why there's TLO72s in some of the mutable circuits that do stuff like this. So what I would want to do is pull in a TLO72, which I don't have room for, and have that invert the signal, and then I would pull it into the MCP 6002. I see now. What you say makes a lot of sense. So we can invert it in software. That's perfectly fine. I can just represent my -10 volts as inverted on the thing. It'll get scaled and inverted mathematically. That's fine. Yeah, so like if I output a negative 10 volt signal here, or let's say I want a negative 10 volt control voltage, I would output from here a negative 3 volt signal that would get amplified to a negative 10 volt signal, but inverted. So I do a positive 3 volt signal that would get inverted and amplified to negative 10 volts. Then when it comes in here, it would get inverted to positive 3 volts. So negative 10 volt CV would be positive 3 volts. It's a lot. It's a lot to figure out and flip in your brain. But it doesn't matter because it's 0 to 3.3 volts. So whatever it comes in as, I can scale it and invert it if I need to. I just got to think about all that stuff all at once. So yeah, I think we're good on that. We're ready to jump into the I2S amplifier. What value is this? 204. So that's 200K. Man, that was a lot of op-amp stuff. But I guess we're fine with where it is right now. PCM1808 board has DC blocking caps, so it would happily take a negative VE input voltage. So negative 1.5 to plus 1.5 input is fine. Yeah, but I don't have, I only have ground 3 volts, plus minus 12 volts, and 5 volts, and negative 10. So I wouldn't be able to power something that can do positive negatives on a smaller voltage unless I did something stupid like use voltage divider circuits. I don't want to do that. So we'll keep the MCP 6004 as our scaler. It's just going to bump it into the DC number line. This'll take it as a positive negative, but yeah, we'll just have to figure out what the scaling factors are. Oh, there's another 204. I gotta put the stuff that we're not using away. It tore into my thumbnail on that one. Jesus. It really hurt. That, like, the plastic of the little clasp on the box just flipped through my thumb. Split it. So 204, 200K. Let me put this one away. Get this out of the way. Because now we are going to involve the microcontroller. DC control voltages won't go through the ADC due to the caps. That's a problem. That's actually a problem because we are measuring that kind of stuff. How do we deal with that? Because yeah, we want to be able to observe AC with this thing. Single-ended analog 24-bit 96 kilohertz stereo ADC, 24-bit delta sigma stereo, single-ended voltage input, 3 volt peak to peak, high performance to plus N negative 93 SNR dynamic range, oversampling decimation filter. So it doesn't have to have the caps. It's just the board that I have has that. 24 bits, dual power supplies, 5 volt for analog, 3 for digital, 14-bit SSOP, high performance, low cost, single chip stereo analog digital converter with single-ended analog voltage input. PCM1808 devices uses a delta sigma modulator, don't know what the hell that is, 64 times sampling, desampling, blah, 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 supports master slave. The PCM1808 device supports the power down and reset functions by means of halting the system clock. Suitable for wide variety, cost-sensitive, blah, blah, blah. Good performance and operation with a 5-volt analog supply and a 3.3-volt digital supply. Fabrication, blah, I don't care about that. Yeah, let me just take a look here and see. Ground, audio data, blah, blah, blah. Those are the pins. Analog supply voltage, 3 to 6.5 volts. Digital supply, 3 to 4 volts. Ground voltage differences. A ground, D ground, plus minus 0.1. Digital input voltage is 3 volts. Analog input voltage, negative 0.3. VCC plus 0.3 volt, or 6.5 volts, whichever you get to first, I guess. VCC plus minus 0.3, less than 6.5. So I have it on 5 volts right now. I wonder if we could then, well, I can't scale it to 0 to 5 because the MCP 6003 only goes 0 to 3.3. Nominal's 5, okay. Digital supply, 2.7, 3.3 is typical. High logic level, low logic level, etc., etc., etc. Left justified I2S, most significant in. Scrolling down further. See what the input application circuit says. See, in chip, it's not doing the caps. They're external, and I would have to remove them or short them. MD1 and MD0 select master mode and slave mode as interface models, both of them which PCM of the device is able to interface mode. Selection MD1 and MD0 prior to power. It's necessary to set MD1 and MD0 prior to power on. So we're in master mode. I don't know what FS. Provides the timing serial audio data communications between the PCM8 and the audio processor external circuit. Slave mode, the device receives timing for data transfer and external controller. So, B clock and LR clock, output pin timing of the clock of PCM8, blah, 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 blah. Okay, data format, I2S 24-bit or left justified 24-bit. Huh. Low and high. I wonder if this board sets them default. Let's see what the board's doing. What the dog doing? So I haven't done any of that stuff. So I'm going to need to hook that up to positive or negative. Are those different grounds? Those are the same ground. Okay. So I can set them, you know, under everything. And then our audio is coming in and it hits these gigantic caps that we can bypass. We're going to bypass those caps. So I'll take them off and then just put a piece of wire on there. But I'm just trying to see, like, if I'm not shifting this on the number line, what is my maximum voltage? If it's 3 volt peak to peak, do I need this to go down at 1.5 volts? That seems odd. Because I need this to be able to take DC voltages in and observe them. It has fade in and fade out functions. So, suitable for a wide reliability, cost sensitive, good performance operation with a 5 volt analog and 3. If it gets a full 5 volts, analog input voltage range, 0 volt peak to peak to 3 volt peak to peak. It doesn't give me a max input. Output is PCM audio data. Should be controlled either by biasing with a 10 kilo ohm to VDD or ground, or driving with a GPIO from a DSP audio processor. Input filter for the analog input circuit, AC coupling capacitor, should be placed in series with the input. This will remove the DC component of the input signal. An RC filter can also be implemented to filter out out-of-band noise. The equation below can be used to calculate the RC. I think this already has that. 5 volt nominal supply and 3.3 volt nominal supply. The 5 volt supply is for analog circuitry powered by the VCC pin. 3 volt is for digital circuitry powered by the VDD pin. Decoupling capacitors for the power supply, blah, 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 blah. VCC that varies from normal 5 volt artifacts, blah, 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 blah. Layouts. Don't care about layout. No, I thought this would be in master mode because there's no other devices connected. We're using the I2S2, after all. The second channel. Computer sources, trademarks. Yeah, nowhere did they say, like, what analog input voltage is going to blow up this device. They always say 3 volt peak to peak. Where's my electrical characteristic tables? Analog supply. Hold on, where's analog inputs? That's pinout. Pinout, maximum ratings. There we go. Oh, so it's 3 to 6.5. I would have much more resolution if I allowed it to get that high. You want slave because Teensy is setting the timing. Okay. I've never done this before, so I don't know this stuff. So, I mean, we can only get up to 3.3 volts, unfortunately, with the MCP, whatever, 6004. We can only get up to 6.5, unless I give it, is this thing only function up to there? So I could hook this up to the 5 volt supply, and we could have a 0 to 5 volt. I mean, I'm still going to get all the resolution that I need out of 3 volts, but I mean, I could set this to be 0 to 5. But then the negative 10, does that still make sense? It does, because we're scaling it inside of that. So let's hook it up to 5 volts, and let's get 0 to 5 volts. I really want to cook this. I want to scale it to the maximum amount of volts that I can possibly punch out of this thing. So instead of hooking this thing up to 3 volts with this, I'm instead going to hook it up over at that 5 volt junction. So what I can do is pull this whole thing up, and then I've got my connection to the op amp right here, and I'll just put that sucker right over there. Actually, what I should do is take it from wherever the red wire goes, because that's the voltage regulator. And that's actually a shorter jump. So yeah, let's just take this. I have good news, but I'm not going to tell you. Then why tell me you have good news? You just want us to plead with you to get that good news. And I can tell you that it's not valued highly enough for us to beg. Nope, we never got the information about there being good news, so just ignore it. Ah, this thing is really hard to remove. Ow! Okay, there. I put the 5 volt thing here just because otherwise there's huge waste of space on this whole circuit board, so I'm unfortunately going to have to go under the device. So we go under the device to get our 5 volts. This is a mess. Whole thing is just a big mess. Where are my tweezers? There. Yeah, I'm breaking some conventions by doing this. Especially with your power wire going under something else it's a pretty big taboo. There we go. So there's 5 volts running to the MCP 6002. And now what I'll do is I'll adjust that. So we need to adjust it to fully utilize the 5 volts that it gets. Power this back on. So now I can take my screwdriver that I lost. What happened to the screwdriver? Put it away? Maybe I put it away. And let's adjust this little guy right here. So I want my peak to peak to be 5. Let's just make sure we're triggering on something. There we go. Seven, 8, 9. There's a little clipping going on there, so we'll take this. The MCP doesn't quite go rail to rail, so we'll take it in a little bit from that. I'll go to 4.8. All the self-measuring stuff is going to make sure that we're good on that. And our voltages go almost down to 0. That's pretty good. So now we've got a full resolution, well, not full resolution, because the thing can take in 6.5 volts, but we don't have a 6.5 volt power supply. We have a 5 volt power supply that we happen to also be using. That was a disaster burp. Hold on one sec. Okay, I'm back. The cooling power of soda. That's just going to cause me to burp more. So this scales it to a usable range inside of the ADC. Listen, I can't get to 5 volts because it's not a rail-to-rail amplifier. It goes very close to rail-to-rail. Datasheet says 0.6 VCC equals 3.0 V. What? Wait a minute. Oh, so it depends on the VCC that we're using. Well, the analog supply is 5 volts, and then it says anything below 6, and our VCC can only go. Why do they do it like this? Input offset voltage plus 4.5. What is that all about? Oh, that's the MCP. Hold on. That's the MCP 6004 can go up to, what is our Vmax? Our input power supply voltage goes up to 6 volts. So we're good on that. Then on the PCM 1808, our analog input voltage is negative 0.3 minimum. And then VCC plus 0.3 volt as long as it's less than 6.5. The analog supply voltage is at 5 volts right now. And that's VCC. So it's 5 plus 0.3. So we're fine. This is totally fair. This is something that I can input. And I guess this down here, I don't think it's above, I don't think it's at 0.3, it might be. But anyway, okay, so this is all well and good. That can be applied directly to the, what do you call it? Directly to the analog input. But we need to get rid of these caps because we are using this analog input in addition to just as audio in, we are actually using it as a DC input measuring system as well, which it should be able to do. So I'm going to get these caps out of here. I'm going to use hot air to do that. It's the easiest way to get these caps out. These stupid caps, they're so annoying. They're made to be an absolute minimum size, but actually I don't think it's a good idea to use hot air on top of the perforated prototyping board. That might be a problem. So let's get this out of here and put it in the vise. And then I'll move this stuff up. Just place it on top of the trash pile where it belongs. How do you discharge caps? You short across them, or in your design, you would put a very large resistor across them that wouldn't affect the power very much, the output very much, and then the cap will discharge over time. Caps can hold on to their charge for quite a long time. That's in terms of absolute and not what voltage range it works in. 1 to 4 volts centered on 2.5. Boop, boop, boop. Where does it say that? I would like to see that piece of information so that I know. Data format, DC accuracy. That's neat. Let's see. Yeah, because I am looking at absolute maximum. That's what I'm used to looking at. So, discharge, digital supply, junction to ambient, audio data format, total harmonic distortion, input voltage, 0.6 peak to peak. Oh, 0.6 times VCC peak to peak. So we need 1/6 of what VCC is. So it's 5, calculator. Why isn't that working? Five times 0.6. What? Really? 3? So we should probably go back to the circuit as it was before. System clock, pulse high, delay, BCK, BDD. We would have seen it in the form of distortion, I guess, and then we would have to dial things back appropriately. What do we got here? Oh my God, what are you guys saying? Do you just want to take over stream? I only know as I've used it myself, yeah. Some people use 2 fridge open incandescent light bulbs in series in order to discharge caps. Really? So those little refrigerator light bulbs, you can discharge a cap through it? I think that would blow up your filament, wouldn't it? I mean, I usually short them out with a pair of tweezers, depending on the size of the cap. But if it's a big cap, they can hold way too much energy, and so you got to be careful. But then again, the way that I do stuff, you don't want to do the stuff necessarily the way that I do it, because I do stuff for stream. I'm trying to make this fun. I don't like getting answers from chat too much, though, because then somebody ends up like driving the whole stream. We were just going to mess around. 0 volt peak to peak to 3 volt peak to peak. But that's design requirements for that specific thing. Why are they keeping this information from me? So going back up here. The starting coil cap from a Model T. Oh, weird. I've got one of those old-timey capacitors in the other room. It was for a thing that makes a spark gap. But I don't want a spark gap because my pancreas uses radio frequencies. I don't want to, destroy all the frequencies. Recommended operating conditions. Over-operating ambient temperature range. Analog supply voltage. Power supply recommendations, 5 volts. Analog input voltage, full scale, 0 dB. VCC is equal to 5 volts, 3 volt peak to peak. So does that mean 0 to 6 volts? And in that case, because that's how I'm interpreting it. It says, 3 volt peak to peak, but VCC is equal to 5 volts. And so I don't know, man. Or do I need to hook this thing up to like positive negative power supply? Do I need to do a TLS72 and have that filter it down and just have it damp the signal input? In which case that would have the authority to blow up the analog input if we set it up wrong. So I got to be careful about that. Jeez. I mean, what I can do is set it to input and output the same signal, and so we can see how it's interpreting stuff. Why don't we do that? Let's keep it the way it is right now and fail, and actually fail at something. Let's actually fail, because we want to do a couple different things with this. So what I'm going to do is I'm going to get rid of these capacitors. We're going to hook it up, and we're going to stop paying attention to all the fucking eggheads in chat who have apparently rubbed their butthole all over this data sheet already. Instead, we're going to fail. We're going to get this wrong, because we're not afraid of doing that here. So let me get these caps out of here. And I'll show you guys how we can fail and still succeed. I'm not personally attacking you. I'm just in general. I don't mean Ben Gizmo. I love Ben Gizmo. Kisses, kisses. I don't mean any ill towards him at all. He's a wonderful chat member, and he's gotten me out of a bind in way more than one situation. But yeah, no, this is it's better to show the process a little bit here. There's some great old caps that have blown up if you're making them too hot. Jeez. Well, these are nice new caps. These will be fine with this amount of heat. I've blown up my fair share of caps in my day. In fact, the only viral video, the only viral clip that I have involves me blowing up a capacitor by accident by putting 50 volts into a 30 volt cap. And it heated up on thermals, looked very pretty. It popped, and I went, fuck! I shouldn't have cursed. That probably kept it from going completely viral. Is that melting or is that just flux? I think that might be melting. My pin header! Favorite way to pop capacitors by reverse biasing them. The troubleshooting analog electronics book that I've been reading goes into, well, it basically says, you know, there's a lot of energy in a shotgun shell, and your capacitor is about the size of a shotgun shell, and it will go off with the energy of a shotgun shell if it is that size. So you got to be pretty careful with that kind of stuff. I know being cavalier around electronics is a thing, but they are to be respected, and we are careful around our electronics here, which is why I never go viral. Nobody likes me. Maybe one day I'll come up with something zany enough. Right now we're doing a lot of audio things, which are cool in their own right. I don't need you to like me. All right, let's get this soldered in. Solder in just a bypass on these caps, and that way we will be able to get DC voltages into this thing and use it as a voltage sensing unit instead of just an audio input. Let's clip that right here. Bada bing. Just using leftover resistor lead. There's no gunpowder in the capacitor. They shoot more like a pop gun. Listen, don't negate me on safety stuff. There's a lot of energy in capacitors, and you can lose a freaking eyeball. Especially if you're putting enough energy into it for it to pop off. That's not a good scene. Pressure vessels are not to be taken lightly. All right, now we do the other side. And we have our non-zero crossing inputs. And that way we can have a DC voltage level, like a control voltage, present on the line, and it will still see it. This right here is just a filter for higher frequencies. I don't know what it would be doing with DC. I don't think it does anything. I'm surprised they aren't designed more safely. It's really, you get it to pop off when you're doing stuff that's supremely damaging, like when it flash steam is produced by the dielectric, it then pops off. Generally, in use, capacitors are used very conservative to their limits. You know, they're way far away from their limits, and they're just going to kind of function for a long time. And when they fail, usually there's just a little bit of a break, and stuff just kind of evaporates instead of it outgassing all of a sudden at pressure. But it's really, when you get popping capacitors, that's when you're going far beyond the limits of what the capacitor can withstand. Okay, so that's where we're taking in 5 volts for this thing, and so this pin has to line up to this row. And this one has one space there, and this thing takes up the entire rest of the breadboard. Now, I'm going to look up how to hook this thing up to an Arduino. And then we'll take the audio input here, and of course, actually, I need to set up, well, we'll look up how to set this thing up to like a teensy. So PCM 18.0 whatever, and hopefully whatever we find will tell me what to set the jumpers to. So PCM 1808 Arduino. What happened? Weird. PCM 1808 Ardu or Teensy 4. Just use the standard I2S. PCM 1808, really simple. You can use either I2S or I2S2. We're going to be using 2 to connect the 4 signals. M clock is named SCKL on that chip. I think they named it M clock on ours. B clock. And SCK, I guess M clock goes to SCK. So let's find M clock. Where is the Teensy? There it is. Here's M clock 1. Is there an M clock 2? Oh, don't tell me it's under the board. I hate it when he uses the under the board pins because you got to do weird stuff. God damn it. Why is it over there? Pin 33. 32 is out 1B, and then M clock is over there. That's so obnoxious. That's so obnoxious. All right, well, we already have a jumper, so all I need to do is transfer that over to the M clock pin. And that goes to SCK. Use M clock 1. What is that? The clocks, are they going to be synced, though? Because we're using serial 2. I don't think that's going to work. It's funny, did we use SCK on the other ones? Yeah, see, I didn't use the M clock on this. I didn't use SCK to get these to work. Do I need it for this? I thought I only need B clock out and LR clock. I2S or I2S2 and the TC4, just connect the 4 signals. M clock is named serial clock SCK1 on that chip. The other 3 of names the same as Teensy uses. PCM 3 config pins, connect all of them to ground. There we go, that's the information that I needed. Be careful with the power pins. Needs 3 volt for digital and 5 volt for analog. If you get them mixed up, it could damage. That's it. That's from the purveyor of Teensy4 himself. The 5102 generates its own clock. The PCM needs the M clock. Okay, all right. So if I hook it up to M clock 1, which I'm not using right now, but I fear that the 2 might have different clock timings. We'll try it. I'll try it. I want to kind of limit my failure points to be 1, but M clock 1 is on pin 23, which is right where that regulator is. Right there next to 3V, and I'll take a big long jumper. Big jumper. I do want to avoid using those under microcontroller pins because they're annoying. Is clock timing similar to car engine timing? The thing is, it could be and it could not be. It depends on how the code handles everything. It depends on how the code is programmed to utilize these different feature pins, and I don't know how that is. I don't know how that is configured. So this could not work, or it could work perfectly fine. It just depends on what they're doing under the hood, and we don't know. We don't know. No, all the outputs come from I2S1. I2S2 is going to be the input. Probably shouldn't say that because you're gonna have some problem with it. Oh, but you can't do that. And it's like, well, wait to tell me that until later. Wear a jumper. It's going to be cold. All right, so we need to set all these to ground. So all I need to do is just do a little leapfrog from this ground pin over here. And the ground pin is 5 volt 3 ground. So 5 volt 3, and now I need to do a couple of these guys. You can use I2S1 as input. I didn't think that it could do both simultaneously. It can? I don't think anything sort of hinted at that. I mean, there is an in pin. We can try that in a minute, but let's just see if this works. Hold on, I'm looking around for another one of these jumpers. I had a couple out here on the table. I don't know what happened to them. All right, let me get a little tiny one then. Let me get one from in here. Does both at the same time. Well, that could free up resources, I suppose. I guess I could have done an input. I could do 2 of these modules, and then I'd have all... Well, I have 4 channels. But if I do a master slave in the other one, I could probably do 8 or all 6 channels as inputs as well. That was the original goal, but I think it's okay to just mux them. That mux seems to work so well for what it's doing. All right, so that's the... Oh, wait, I need one more. One more. There's 3 address pins. Address and frequency pins. All right, thanks, Bing Gizmo. Have fun. Is that all of them? So 1, 2, 3. 1, 2, 3. Okay, cool. There we go. So 5 volts there. Like that. Get this out of the way. If I do it all on I2S1, but then, so I would be plugging it all to the same LR clock and B clock, and then I would go into in1. In2 is right there. Huh. Well, but wait, the audio tool yelled at me when I tried to do that. Hold on, let's look at the audio tool here. This is a Node-RED style audio tool that helps you configure the microcontroller to do all this cool stuff. So what I have are all of my waveforms here going into the, rather going out of the I2S. But can I have an I2S1 input? We're not doing output, we're doing input. And so I2S, drop that down. It looks like I can. Wait, so we can do this all on just channel 1? All right, we'll try doing it all on channel 1. Why not? So that means that my BCK and LCK and all that stuff, I can bust some of them together, and I can actually get them from a different area, and that simplifies this part of the layout quite a bit. So I'm going to rip all that stuff up. It's all gone, all of it. So in this case, our serial clock is going to come from over here. That's going to be the one that jumps the most, so we'll do that last. But now my M clock and LR clock coming from up here, going through all of these and daisy chaining up the line. That's what this line, actually, yeah, that's what these are doing. So this can go to here. So let's take that. Let's figure out what that is. All right, so this one in the back goes to pin 20. The way you tore that out scared me. Sorry. You got to choose your battles here and do stuff very dramatically, and it makes things more fun. So LCK. LCK is there. LCK, so we need to go here to here. These are nice short jumps that makes things a lot nicer. Although it will violate my the principles that I tried to stick to, which is not to have wires cross over one another. I can't really do that here. It's just going to have to be that way. So LCK goes to LR clock, and then this one is BCK, and that goes to BCK. I need another orange. Where's an orange yumper? Orange yumper. BCK. Okay, so that's those two. And now out goes to in 1. Out there. And then over here, in 1, I'm going to look at my teensy guide here. Pin 8. It's way over there. Pin 8. That's way too big of a jumper. Need something a little bit smaller. I don't know if what I have will work. Green is the smallest of those, so it's probably not exactly going to work. Oh yeah, let me look at Streamlabs here and make sure that I'm up to date with everything that's going on. Code Rushed with a party of 20, which is an amazing raid, thank you. And then Econ 1972 raided with a party of 1 2 days ago. So yeah, I'm up to date with everything. Thank you guys for the follows. All right, so let's go from in 1, pin 8, to out of the analog to digital converter. Man, I can't keep A to D and D to A straight in my brain. I'm an old man and set in my ways. And then, okay, M clock, which is MCLK1, which is actually, that one shouldn't have been ripped out. I shouldn't have ripped that one out because it's still going to the same spot. So this one goes from here, SCK, over and around this little area in between the two boards. And it goes to 23, which is the blocked pin. And there's our clock. So our clock goes all the way up and around. That could be shorter. We're going to get shorter. I'm going to get a shorter wire for that. There's a certain, you want a certain amount of neatness on your breadboards, otherwise the chaos takes over. Where nothing is sacred. I can't see what I'm doing. Tweezers? Here. On this pin. Right there. See, the problem with this is that these are going to be pulling each other out. I wish there was more room to work, but there just isn't. Sometimes you can get away with, like, you jump this to like another row and use it somewhere else. But anyway, so okay, now we have, this whole thing is hooked up. All of its addresses are configured. It should be good to go. We have our 0 to 5 volt. It's like a 4 volt. It's like a 0.1 to 4 volt signal coming out of this op amp. So this hooks up to one of our channels, L or R. So what I'll do is I will get on jumper. Oh, what came out here? My ground signal came out of here. Now we know that this thing can go up to 6 volts. It's just what is usable. What is the usable range of this op amp? Or sorry, this A to D. And so we'll figure that out by routing our audio from the input to an output. So we'll just make channel 2 into, well, actually, wait, we don't want an infinite feedback on that. Channel 1 will be that thing, and then we'll make channel like 8. We'll make channel 8 be the output from the data this thing is getting in. So what we'll be able to do is we will observe it over here, and if it gets to that plus minus 3 volts, that means that we are able to utilize the entire input range. We're getting all of our numbers from positive to negative on that. Use the test to take the test. So what I want to do, oh wait, I'll hook up the audio output. So audio output goes through, where's my bendy flexi one? I had a special wire, here it is. So that goes to the output for the op amp here, and into, well, we'll just put it into the left channel. Just like that. So now our full loop is hooked up. And I can go back to the PJRC audio tool, I2S2 right here. And let's see. Ugh, hold on, stuff in the way. We have a bunch of examples. We have a bunch of things that can be observed. Object is used with the audio shield, which is controlled separately by the SGL. Only one I2S input and one I2S output object may be used. Masters and slave modes may not be mixed. Both must be the same type, blah, 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 blah. Okay, so I2S2, I don't know what the order of these outputs are. Oh, 0 left channel, 1 right channel. So we'll take this channel and let's actually get rid of this connection, and then we'll take this channel and we'll put it into channel 8. So whatever we receive, we are then going to output on the 6th channel, technically the 8th channel, of our I2S. We're just a big feedback loop now. So export that, and let me copy this code. Click OK. And now I can go into our microcode, and I can set up this stuff. And now we have that extra connection, and we have audio output I2S, I2S octave 1, and that's it. That's all we're going to do, except we're not going to use waveform 6. Although, wait, waveform 6 isn't connected to anything, so actually we're just good. This is just going to work the way it is. All right, so plug in the Arduino. Wow, all that was a pretty heady programming session. That was a lot. You guys were very good to be very patient for all that programming that I just did. I've clicked upload. Please respond. Now take cover. Now move. Compile, compile, compile. Oh, hey, Madam You, how's it going? Sorry, I wasn't looking over in that direction. On the subject of your muscles. Oh, for the cramping? Yeah, maybe I need to eat a banana. I don't know. Were those showing up, those YouTube comments? Sorry, YouTube. For some reason, you guys were not showing up on the social stream blade. You guys haven't been showing up on screen. Hold on, let me go through what you guys have been saying. Humid, hot, salt and sea. We got that stuff. That was from a while ago. Craftsman tools. We got those messages. A couple of sockets that I discovered I had for over 10 years that I broke myself by using them. Took them to Lowe's. Really? Oh, that's cool. That's where I found out they don't do a swap. Oh, but they, yeah, I guess it depends on the place now. I don't know. Maybe it is potassium. Maybe I peed out all my potassium by overhydrating. But anyway, how's it going, Madam You? Okay, so now we have supposedly, because this thing is, yeah, it's all programmed up. Turn on our output so everybody gets power. What the heck is going on with that? So right now I am observing, yeah, something's not working right. Yeah, that ain't working right. What the heck is that? It's like sub-audio waves. Looks like a fun song. I know, like suddenly it's a some kind of an LFO. Is it because this ground isn't referenced properly? This is going to that channel, and that channel is not giving us an output. The output, oh wait, no, hold on. I could hurt this thing. This goes over here. Yeah, we're not getting a proper output on this channel. Why? Why do you not output? Is this thing plugged in wrong? Like I could be 1 pin off? No, I'm not 1 pin off. That's plugged in as good as it gets. Is it that this specific channel is not outputting anything? Oh yeah, it's that channel's not outputting anything. Where's this channel? Okay, this one's blue. Works there. Works there. Doesn't work there. And yet that's the channel that we're taking our output from. Works there. Works there. It's a smash hit. You guys can't hear anything. This is the 3-volt power supply. It's kind of cooked. It gets very, very hot because it's getting near its limits. It might even be a little bit past its limit. These 3 devices use 3 volts. This uses 3 volts. And I've got them run on their own little 3-volt supply loop there. It just gets very warm. But it is still running 3 volts pretty accurately. Well, it's actually a little dirty. That might just be because of ground issues. Okay, so why did everything die? This is doing nothing because that channel is disabled. We've hooked up, from what I understand, we've hooked everything up properly over here. I've got 3 volts running to 3 volts. Check the power and grounds. So 3 volt there. Well, 5 volt here. Yeah, yep, there it is. A little 5 volts. Then we have M clock, or SCK is there. That's another I2S. There's that one. And we have another signal there. These are just grounds. This should be at 3 volts. It is. So we're getting all of our powers in. We have signals on all of our lines. This one's ground, yeah. And then our signal over here is not happening. So what's going on with that? Maybe I disabled the wrong waveform. Waveform 1 to 6 are being defined, but the waveform, oh, it actually, oh, there it is. Waveform 6 is up there. Yeah, they're all there, but waveform 6 isn't actually connected. Instead, I2S1, 0, I2S octave 1, I2S oct 1, patch cord 1 from, yeah, 1 to pin 7, waveform there, oct 1, patch cord, got the audio memory. It's not showing, I guess it's just the patch cord is just what's powering that. Because we start the waveforms here, but how do I output? Well, that should just automatically output whatever the input is. Actually, don't need Notepad++ open right now. I2S1, and then the out 0 is the left channel, which we are plugged into. But then why would waveform 2 be what dies? This is what died. Waveform 2 begin, waveform sawtooth. Oh, or is that waveform 2, or is that some other waveform? Is this the output from our input? In which case, this is the channel that I'm amplifying. So if I take these and I reverse them, there. Now we have a sawtooth. Oops, hold on. And then channel 2, no, channel 2, channel 1, lower that down a little bit. There's our plus minus 10 volt coming out of channel 1. And then if we observe channel 1, that should be going all the way until our buddy over here. Well, it should be coming out of here, and we're not getting it out of here. Why isn't it coming out of there? So this one goes to... Oh, wait, it goes to a different channel. So let's find our buddy over here. Wait, why did that die? Wait, why does... Wait, huh? Oh, I see. Yeah, the yellow wire is not... This is actually the other one. So wait, that channel's still dead. What happened to this channel? Is it something that's happening like... No, it's... Wait, that's a different... So coming from... Yeah, digitally, that channel is dead. And that one corresponds to L or R over here on this first output, first stop for the signals, hooked up in exactly the same way as all the other ones. It's just a dead channel for some reason. Why would that one channel die? Something's happening inside of here that it doesn't like. Unless that one was technically channel 5, the one that I unhooked. So if that's the waveform that represents what's coming in here, then check over here to make sure that we are outputting our own signal here. So yeah, we've got a signal here. What is the amplitude of that? Channel 2. It's 0 to 5 volts, okay. So then I input that into the codec, or the ADD. And what we should get is this channel giving us data. Ha ha! Look at that. So, okay, where's the scope? Is on a different channel. So the scope needs to be here. Look at that. So here we have audio going into the codec, being turned into I2S, output out of this, going into our amplifier, into the mux, tamped down by this amplifier, coming out, going into this. So it's a big circle. We're creating a waveform here, and then we are observing it over here, and we're outputting it on a separate channel, and then observing it over here. It's very... Wait, why did it all die? I touched it. Wait, what are we doing? Hold on a minute. So we're creating a waveform arbitrarily, putting it into our amplification stage, so it's plus minus 10 volts, putting it into what would be our input, I guess, muxing it so that it switches between any of the waveforms, but it's we happen to be choosing that one, inputting it into here, and then we are outputting it out of a separate channel to observe it. I love this stuff. I know, right? This tickles the nerd brain. Tickles the nerd brain. So what we're doing is we are creating a signal here, looping it back in, and outputting it on a separate channel. That's what we're doing. And we can see that we have distortion. So this cannot express that fully. So what I can do is adjust this. I can adjust it down so that it fits. And there it is. Just a little tweaking of the knob. And now we know that our I2S signal can handle inputting plus minus 10 volts, and it'll get it into range so that it's able to digitally express. Because remember, the whole point of this is that the numbers that come into this, don't nudge it. The numbers that come into this are digitally expressed on I2S into this processor. I can't believe we did that with one single air wire. That's so weird. We did that by adjusting, it's so little code. By doing this, we just drag and drop this thing in there, this little I2S1 input, and we poked it into our output, which is, it's weird that it went to that one. Channel 7 is channel number 8, but that's not channel number 8. I guess that's just because I hooked this up here, and this is output something or other. Oh, what's going on there? What was that? So what we can do is we can keep this running, and we can try to add to it I2C, serial port, button inputs, and the screen. This is essentially the whole analog setup that we've done right now. All of the analog stuff has been done, except for the MOSFETs, or the 3904s on the input that will be our gate signals. But this is a huge thing. This is a big achievement here. And if I wanted to, I guess I could switch to other channels by altering these inputs over here. We can hook that up and maybe hook it up to like a button or a knob. Here, let's I've done stuff with a 3904 before. Oh, and then the other thing is the other cool thing is part of the 3908, the MUX, The mux is also connected to as strong of a positive and negative voltage signal as I can get to. This thing is going to be catered specifically to 10 volts. I can't quite make it operate at 12, I don't think, because it's not, I can't unbias the 10 volt enough for it to properly operate at 12 volts. So whatever positive and negatives I can get, which is basically negative 10 volts and positive 5 volts, I have on 2 channels of the mux. So when we boot up the system, I will be able to flip the mux to those channels, observe what the input values are, and take those for gospel, output the values on these channels, and then mux to those channels and adjust those channels so that they're accurate. This is cool. This thing can observe itself and get it into working condition using a bias voltage out of something that's accurate. So I have the 5 volt voltage signal is pretty accurate. The negative 10 is a voltage reference. So it's able to actually completely reference itself. So everything will be able to adjust itself automatically without, me having to tweak knobs. And then we'll rule the world. And then we'll rule the world. Yes, yes. Anyway, that's cool. This is like, what are those things called? Like the word cascades, where the sentence like cascades on itself and becomes this crazy thing. Are you thinking what I'm thinking, Pinky? Okay, that is progress. This is some shit right there is what that is. This is a lot of work. It was a lot of work to get this whole thing up and running, and this is only one part of many. But it's nice that we didn't have to use 2 channels of the I2S. I2S can receive 2 channels and output 8. It can output 8 channels, and we're only using 6 rather. Sorry, we're only outputting 6. The data right now is arbitrary. I've made them into waveforms, but we'll be able to control and change and predict and do all kinds of cool stuff for that. I don't know exactly how I do that because we're going to be flipping functions on a lot of stuff. I don't know if I need to have like a waveform plugged in and like a DC voltage level plugged in. Well, let's check a DC voltage level. Let's get rid of like waveform 2. And let's take, let's see, a DC voltage level, and we'll put that into channel 2. I don't know where channel 2 is, but... So DC1, audio synth waveform DC, create a constant DC signal, output 0, output constant DC level, amplitude and level, or amplitude level in milliseconds. -1 to 1. Reads the current level. Okay, so is the Arduino generating the clock? Yeah. And when it comes to like tempo and stuff, I'll have to have it do that as well. But right now we're looking at DC voltage level stuff. So let's just see if we can get a DC voltage output, and if we can observe that DC voltage output back on our equipment and have it set our observation channel to that. That'd be pretty cool. Oops, I hit Windows. So now we have DC1. So let's see, what am I doing? I'm doing create a constant DC signal useful for control of objects that take a modulation or control input signal. This constant level can be used to modify other waveforms using a mixer or multiplier objects. So let's set it right in the middle. Set it to 0.5. Well, it's -1 to +1. But that's levels output is gradually changed over a millisecond's time. -1 output is changed immediately. So -1 to +1. What does the command look like? It would be DC1.amplitude. So what does that look like in here? DC1.amplitude, and then it would be 5. I don't know how accurate that's going to be, but we'll just see. Okay. Compiling. Takes a little while to compile for it being so simple. These audio tools are going to take a lot of the guessing work away from me, and I'll be able to make this thing a lot faster. Okay, so now my code's in there. So now we take a look and see if we can find our DC amplitude. So that would be the blue one. Nope. 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 Aha. And lo and behold, 0.5 on a scale of 0 to 6 nets us 3.8, almost 4 volts. Well, an amplitude of 1 would not be, but still, we're outputting DC, right? So if we're outputting DC, I want to be inputting the DC again and see if we can observe a DC voltage level. So if over here we're on this channel, this is our DC, I want to put our output here to this input. So I'm going to swap these two. It's going to get a little confusing. And then I should be able to observe another channel that is just at a fixed voltage level. So this should be at a fixed voltage level. It's not, it's still on triangle wave. Which one is that? Is that this one? Yes. Okay, so it's actually the first channel I want. So I want this to swap back with this. I'm just using this area as a switchboard. So if I swap these two, wait, which one's my DC? Oh yeah, I put it back over there. So I take this one, I go over here. Now we have, wait, that's triangle. Well, that one is at 0. What is this one at? That's at our DC voltage. So we should be observing a DC voltage over here on our scale that should get us a DC voltage output. There's our input. What's that one? That one's just nothing. This one is supposedly our output, but it's not doing anything. That's trouble. That means that we're not getting something in that gives us a voltage level. We're just getting a nothing unless the waveform is moving. Oh, maybe we are getting something. Wait, it bumps up for just a second. Like if I keep giving it data, it'll jump around, but yeah, it doesn't like receiving DC, which is a problem. That's a big problem, actually. Do I need to double these up with an analog input, and that way I can observe whether or not it's 0 to 3 volts? 0 to 5, I guess. I'd have to put another amplifier on, and it would have to work in the positive to negative 10 volt range. Because if I'm observing a direct DC voltage, if it's going to be doing these shenanigans, then we're in trouble. Oh man, that's obnoxious. I guess that means I can put the capacitors back on it. Because yeah, see here we have a voltage reference level coming out of our whole system as 3 volts, 3.1 volt, going into our coda, or our A to D. But our D isn't displaying to us why is that? Yeah, 3.06 volts. But then our A to D is not responding with data pertaining to it, as if there's another DC block going on. That's what we should be seeing. But instead, we get nothing. Good day to you, sir. Oh, that's annoying. That means that I can't observe the -10 and 5 volts on that. I have to observe it on this, in which case I don't know about the accuracy of this. Oh, that's really annoying. Are there A to Ds that for I2S that can take in a DC level and not do shenanigans like this thing is? What's going on there? Some kind of a weird thing. Yeah, this second channel here is the output, and then our input is coming from here. And if I flip it, so the white wire is our observation channel. So if I observe a different waveform, or is it? Wait a minute. Yeah, that's biased there. Wait, what? Hold on a minute. What the heck? I may need to clean up my wiring or get the mux working. Why is that just like a blank channel? Or is that my feedback? That one can't be the output. Whoa. Oh, wait, something's happening now? Now we're getting a triangle? I'm putting a triangle into the mux. That's what's going on. Or putting a triangle into the input. And then that should be outputting the input somewhere. So I should be seeing that reverse. It's either that one or that's our DC. I thought it was this one before, but that one's just blank. I think I need to clear up what the different channels are. Whoa, why does that get more crisp when I wait? Why are we heating up so much? Are we heating up or oh, I see. This is the 5-volt source. Yeah, that's just warm to the touch. It's not hot. All right, let's see here. Whoops, where did that? Oh no, my window. Bring chat back. Where's chat? Where did you guys go? There you are. There was a reverse sawtooth. Hold on a second. Does it need a time value too in milliseconds? No, it appears to be okay. Yeah, no, we appear to be getting our DC level output out of this. Now it's scaled on from -1 to +1. I don't know what that quite means. But when I observe it, it looks like this. No, it doesn't. There. So that's our DC output. So we're able to output control voltages from these. We'll just have to figure out what the scale is for like volt per octave and stuff. But that will then get scaled up to the, you know, the full range. Oh, excuse me. So this here, red wire, goes to this channel, which is not currently selected. So that voltage looks like this. Oh yeah, because it's inverting. So that's going to make a strong negative voltage out of it. So as that DC level moves around, it'll be able to go from negative to +10 as a control voltage. That's perfectly salient. It's perfectly reasonable thing for this to do. Or it could just die. What just happened? Who is so sensitive that they just kind of go crazy and die like that? Okay, so yeah, we've got that strong value coming out of our amp. So we're able to make control voltages, right? I'm able to make control voltages and I'm able to influence control voltages. That's all well and good. But when I put that into the analog to digital converter, it just goes away. It just goes away because of the zero crossing biasing. You'll match these waves to musical octaves. Yeah, I'll probably have a mode where it can output like song type stuff. So that voltage is going into the mux, into the MCP 6004, and it becomes a 0 to 5 volt signal. I don't know why it's all the way up there at 5 volts. It probably shouldn't be, but it becomes a 0 to 5 volt signal. So that it's blasted up into the negatives, and then it's scaled back down, and then it's put back into the audio codec. The problem is the audio, I guess I'm calling it a codec, it's not really a codec. The A to D is then communicating, hopefully, that voltage level back to this stuff, where it then directly puts it out of this thing. And so that's coming back on this channel, and it's just not working. So if I take my red line here, oh wait, that doesn't, wait. The feedback channel should be a different, no, but if I'm getting, but I'm not selecting the pin, maybe something else is wrong. Maybe I need to hook everything up again. So output from here is supposed to be DC. If I blank this out and I put this over here so that we're not observing anything, and now that channel should just be at ground, and then I'm going to take my probe and move back over here, and I'm going to unhook everybody. So we'll take all of these and bring them over here. And not short everything out. I don't want to short anything out. Okay, so here are all of my outputs. Here are all of my outputs from this stuff. So we look for whichever channel. So this one's a DC wave, a DC signal. These two are blank. Why are you blank? Shouldn't be. Oh, they just got a little squirrely with their timing. Okay, there's square wave, there's triangle wave. So, if we observe this channel, the output channel, which one of these probes is going to get that output channel to do stuff? Not that one. I say probes, it's just like patchwork. We want to short everything out. No! No. No, I do not. Short everything out, make a big explosion. Everybody's happy. Nope. There's a lot of complexity here right now, so I'm just trying to kind of simplify things so that I know that my test failed. Oh, you know what I'm not doing is feeding it back. Whoops-a-daisy. Now I got to test all this again. Nope. I feel like it's going to be one of these. Nope. Nope. What's going on here? No, and okay, so something else is going on. All right. So let's think about this for a second here. Let me observe what we're pumping into the DAC, the ADC rather. What we're pumping into the ADC, for some reason, is a positive voltage level, even though we're not feeding anything in there. Strange. I guess that's its 0 point. So nothing there. Let's just walk through and find it. Hold on, I'm going to release all of these and just get them in order. Two there. These two here. It's a very strange system that we're working with. It's complicated. These two here, and then these two over here. Okay, so the channel that I thought it would be, well, it should be the first channel, which is the red wire. And the red wire goes here, and that's this wire here. So if I give this an arbitrary signal, We should be seeing it on the outset. For some reason, we're not. Oh, because that channel's dead? Because they're all dead. Wait, is everybody dead? What is going on? Works. Doesn't work. Doesn't works. DC offset. This one failed. Why did you fail? Master Wayne. Why do we fail? There we go. That one's back. Why are these so sensitive? Jeez. And then observing here. Okay, now we're pumping the square wave back in. So there's the square wave. So this is the send channel. There's triangle. This one should be DC, but you can see how it sort of tries and then it just kind of fails. There's that one. So this codec, or the ADC, does not operate with DC at all, even with the capacitors bypassed. What's up, Pyro? So what we're doing right now is we have a bunch of waveforms that are being output on the DACs. A bunch of waveforms, those are being amplified and then sent to a MUX. And then the output from the MUX goes into an MCP 6002 to damp it down into the audio range, the range of our analog to digital converter. And they're all on the same I2S line, and they're all running inside of the Arduino. And then we have another channel that will output whatever this thing is getting in, so that we can make sure that it's able to express all of the proper voltage values in its repertoire. We can see that it's not clipping. So what I'm able to do is change channels like the MUX. I'm acting like the MUX here, and I'm outputting different voltage levels. I mean, if we chopped the DC level, if we chopped it, if I put like a little tick thing, then we could observe the DC level based on the ticks coming in. Or I could scale it down to ADC level and have it go into the ADC. That's pretty obnoxious, though, that I can't use this thing in order to measure a DC voltage level. Because when I do, you can see it just kind of like gives up. And you can observe there that that's what voltage level we're giving it. Or wait, no, this is what we're getting out of this one. Yeah, it's the audio thing just kind of hangs over there. But we can also see the DC voltage level input from there. It's just when we try to give it DC here. Oh yeah, that's right. This is output. Peanuts. I mean, those do look similar, but I don't think that's how this is working. Oh no, they look similar because they're the same, yeah. We should be seeing that same DC voltage level coming out of here. Actually, when I tried running an old Intel HD audio compatible codec on an ESP32 or something's I2S lines, if I can ever figure out how to talk to them in their configuration interface. My favorite is the obsolete VIA VT202. Huh. Looks like analog ground is not connected to the ADC. Oh no, it's behind. It's hooked up behind this. Wait, ADC. Are those separate grounds? I mean, I can just hop that ground over. Let me turn this off. Let's pop the ground over and see if that does anything. So that second pin goes to third pin. Actually, we are doing the addressing and timing with this ground because it's connected to the same ground. Because that goes down there and it goes under the board. Yeah, they're all the same. Every ground pin is the same ground. It's all the same. Plus, we're getting perfect results when we have actual audio information going into this, as opposed to just stuff to ground. That goes to the same ground as everybody else. I'll check. Yeah, it's the same exact ground. Everything's going to the ground plane. Oops, I unseated my 5 volts. So it's ground 3v3 5. Let's close it like this. There we go. Okay, and then is that still plugged in? Yeah, okay, that's still plugged in. Darn. Well, this is why we breadboard. We learned something about this specific one. Are there ones that do DC as well? Because our whole loop thing is designed to vet out the A to D converter. So I've got the I2S running directly to an output over here, and then I've got DC running to a different output. But unfortunately, it's all messed up. Unfortunately, it doesn't do DC. It just kind of cancels it out. Test circuit. AC and DC test circuit. Wait, what? Wait, hold on a minute. VDD, V out. What about DC? Wait a minute. It's all frequency response stuff. I'm just trying to see whether or not this thing will pin descriptions. What the? No. Oh, this is MCP 6004. Oh, that's why it said AC and DC. Sorry. Wrong data sheet. They all look the same. PCM 1808, high performance, low cost, single chip, blah, blah, blah. Single-ended voltage input, 3 volt peak to peak. Oversampling, high voltage, PCM audio interface. Data formats, power down and reset handling by system clock. Low pass filtering. I mean, the way that I could do this is doubling it up, but I would like this thing, like I wanted everything to bias to itself, you know? Look, a strange choice by the manufacturer to force ground as reference voltage. Well, it's audio, so it's in reference to ground. You know, it's all positive and negative from ground. That's just how audio does. Schmidt trigger input 5 volt tolerant for clock. Huh. 5K ohm, 50 kilo ohms, internal pull down. But those are for the data lines. Yeah, I wanted this thing to be able to measure a DC voltage. It's unfortunate that it can't. TC 5 volt, 3 volts, blah, 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 blah. That's weird, though, because how does I2S function that it can't measure DC? Isn't that what it would be doing? Or would it be describing frequencies that need to be output? That seems a little weird. I don't know how. I maybe need to read how I2S works. Or maybe we can do PCM 1808. Measure DC. Hold on a sec. Let's go to old Reddit so I can actually read this crap. Oh no, have they disabled old Reddit? It's gonna pay. It took me back to www. Oh, whoops, no, stop doing that. Pay.reddit. Pay.reddit still works. Wait, what's going on here? It didn't work? Oh, whoops. It went to a search by accident. All right, so hold on. Turn that into Pay.Reddit. They said they wouldn't undo old, so I probably just messed up the URL. Intending to design a digital guitar pedal, and I was wondering if somebody has experience with the TI PCM-A208 ADC. Main doubts: already accepts signal centered on ground, as it is an audio-oriented ADC, and if I'd have to reduce my signals to 1.5 peak, as it mentions 3 volt peak to peak in the datasheet. Signal needs to be centered around Vref, which is normally 0.5 times VCC. Centered around Vref, huh? Easiest way to do this for audio signals: AC couple them. I want to do the opposite. I want to do weird stuff. Clipping happens at 3 volt peak to peak. You should probably design your circuit such that the upstream device clips around that level. Okay, that's not really, that doesn't help me. I want to get a measurement of DC current or DC voltage out of it, because then I can set up reference voltages to make sure that everything scales properly numerically inside of the device. So if I'm outputting 5 volts, I know it's 5 volts. That would be ideal, but it doesn't look like I'm able to do that. Let's see. Rack store. PCM ADC evaluation module. 10 pieces of it. The only way that I could get a good measurement is if I put it into an op amp and had it invert and uninvert the incoming signal. Then I would get like a positive negative. That doesn't make any sense. That doesn't make any sense, Bother. What are you doing? I'm gonna have to think about this a little bit. I'm gonna have to think about this. I don't know what I can do, because it seems as though the measuring of the signal is done somehow internally that doesn't match up with measuring DC. I don't know why that is. And there's a pass filter on it, but if, I mean, this would be DC blocking, it should still go in just fine, because there's no frequency element to it. I don't think it's the fault of the filter. Ground pore separating the left and right channel traces to help prevent crosstalk. I wonder if that's been done here. Now, okay, so the next question is there another type of I2S audio interface that I can use that will be able to measure DC? Don't you dare, AI. PGY I2S electrical validation and protocol decode software is a tool that can run on Tektronix oscilloscope to perform shut up. TLV 320 AIC 31110 ADC voltage for full-scale dynamic range I2S. Holy shit. What does it even mean? I'm using the blobbity blah with blobbity blah to record an audio signal. First question is related to ADC full-scale voltage needed in the MIC. I have a pure tone generator. I use it to emit a tone that is read by the microphone. The microphone is connected to the amplifier. Amplifier is connected to the mic 1RP. I'd like to know how much voltage I have to measure to get 223 counts of the I2S. What the fuck? Okay, no. DC control voltage output. Possibility of using audio. There we go. Possibility of using audio codecs for measuring DC stuff. Running the ADC from a stable supply voltage won't solve everything. Are we in the middle of this conversation? Yeah, we're on page 2. Hi, I need a cheap way of reading and generating precision DC voltages. I was wondering if something like UDA 1380, which is an audio codec, or similar ones can do the job. What are the pitfalls? What are their inob? For example, the UDA says the signal-to-noise ratio is 48 kilohertz, 97 dB. So can we calculate that enob is, oh, Jesus Christ. The DC filters, blah, 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 blah. I need ADC, DAC with at least 16 enob with low price. Didn't look specifically at the datasheet from UDA, but general picture with audio codecs is that they don't care too much about DC offsets or gain. In practice, the gain variation of most of them is not that bad. A temperature coefficient, temp coef of 25 ppm seems typical. It's the DC offset you need to worry about for a good DC measurement. Not only can it be quite large, it isn't always very stable. Audio codecs generally have horrible DC characteristics. Up your budget a bit and look at the LTC 24XX parts for some serious DC precision at a bargain price. I don't like the look of that. So, hi Pyro, I saw you earlier. I'm kind of wondering about this. I mean, the other thing that I can do in order to measure DC, the problem is it won't be able to characterize. Like, I was hoping that this thing would read the DC over here, and then that would be able to scale it. And then I would be able to read the DCs from this and have them all be in the proper scale. But it changes everything. I mean, what I can do is, I guess, well, no, because I can't read the DC from these guys. Oh, you're replying to NanoCat. I didn't see that. Oh yeah, I can't see that on my social stream, Blade. Weird. Back to lurking. It's all right. I'm kind of running into a wall here. This is where I'm trying to consider what my next move is going to be, because this means that there needs to be some other kind of observation device sitting on this network. And I do have an ADC. I have an ADC that I have an I2C ADC, and then this thing as an ADC that I could use as well. I don't know what the voltage levels of the ADC that I have are. I have an I2C ADC right here. No, that's an ADXL345. I have one. It's just... This is so annoying. This is so annoying. It has to get a little bit more complicated since this doesn't observe DC. I don't know how I could do qualification. Get this to run at a certain voltage level, then send like a wave into this, and then observe what that peak to peak is, and make sure that it matches up. I think that's the only way that I'm going to be able to do it, is if I take a voltage in and I use that as a control voltage for an oscillator, and then I can observe it, and then I can still use all this hardware. It's just that I need both of these channels to go to their own ADC channels on the Teensy, but the problem is I have to bias them differently as a result. Currently, we're biased up to 5 volts. So if I could find an ADC that would be able to operate within that voltage, then we can use that in order to calibrate and scale everybody else, and I can get DC voltage measurements in the device and be able to say whether or not something is like 10 volts or 5 volts or whatever. Voltage level shifter. Not that one. Somewhere in here, there is an ADC, I2C ADC board, unless it made it up there. No, it's not up there. Okay, so let me look around here a little bit. (16-bit) I2C, ADC, and PGA. It's an ADS 1115. Where do we use ADS 1115? ADS 1115. Let's just look that up real quick and see what its requirements are. That gives me 4 channels of A to D that I don't need. I don't need all this. All right, let's see. ADS 1115. With PG Pro Gain Amplifier? What did you do to start doing all these things? Always tinkering with electronics. I mean, we're doing modular synthesizer stuff, so it's like that was a whole push from a friend of mine. He's like, you know, you need to build me a synthesizer. Sir Hiss, the henchman. How's it going? So ADS 1115, and I just want to get information about it. It's another TI chip. 16-bit 860 SPS, 4-channel Delta Sigma with PGA oscillator, VREF comparator, and I2C. Okay. We are going to be using it for a pithy amount of its capability. precision low power 16-bit I2C compatible A to D converters, ultra small lead package, programmable gain amplifier. What does that even mean? Power and space constrained sensor measurement applications. Well, that's what we are. Conversion data rates up to 860 samples per second. We don't need that. I don't even need 6 of the channels. I only need 2 of them. How would you say somebody like me should know computer science but nothing about electronics? Oh, you're in a good position then. Yeah, if you get like an Arduino board, every single project and its subset has been done on Arduino. So if you get something that's common, like your basic Arduino like kit, it'll come with stuff that you can kind of poke around with and build up a little bit of confidence in doing stuff on things like breadboard. Yeah, and you can, I mean, never skimp on the basics in the project. Don't think that you're smarter than the basic project. Do the easy stuff. Blink the LED. That's I haven't started out in this in a long time, so I don't know what the best jumping off point is. But I mean, you got to start with something, right? You got the CS degree. You know a little bit about microcontrollers. So if you go with Arduino, you can get pretty far with the capabilities and the ability to search any of the problems that you're having. Arduino, ESP32, Raspberry Pi is the normal progression that most people go through from what I see. Why ESP32? I mean, Raspberry Pi is okay, but it's too much. It's too much. What we're doing right here is a stress test. I have 10,000 channels operating on this thing, and we're making sure that our microcontroller is able to handle it, and we're running into the weird kind of problems that we would run into in a system like this, because we're doing audio stuff. So what we have going on right here, right now, is I have an I2S, the microcontroller is running I2S, and it's outputting 6 channels. One of the channels that it's outputting is actually just the input. So we get an audio signal in, and we immediately output it onto one of the channels. The other channels are arbitrary waveforms. One of them is a DC voltage level. So we take that waveform and we boost it from the plus minus 3 volts that this thing provides. We boost it and we create plus minus 10 volts. That plus minus 10 volts then goes into a MUX, which we're not currently doing anything with, where it's just in there because it's part of the system. And then our MUX signal is then applied. Hey, you come back here. Our MUX signal is then applied to an MCP6002, which is an amplifier. The amplifier is damplifying it. It's damping it down and limiting it to 0 to 3 volts because this, well, it's okay, 0 to 5 volts because this thing can only input 0 to 6 volts. And so we have that coming in, and we were able to scale it very specifically so that it would fit in the audio codec. So if I switch channels here to something that's outputting a wave, well, this should have come to life, but for some reason, poking the bear, if I poke this stuff wrong, it all goes to hell. Oh, that's right, I turned everything off because we were looking up stuff. So, ADS 1115. Go to our max, absolute max ratings. 7 volts max for the power supply. Analog input voltage, 0, 1, 2, and 3. From ground to 0.3 is the minimum. The maximum is VDD plus 0.3. So if we give this thing 5 volts, this thing will be able to operate within our tamped down voltage. Site Zero, thank you for subbing with Prime for the 2nd month. Hell yeah. GitHub has a bunch of awesome device name lists that have a bunch of really cool projects you can try with different devices. For example, here's the Raspberry Pi list. Oh, cool. That is very cool. Site Zero, thank you so much. Yeah, you guys are better at helping people out. I don't know where to start. Most of my projects are spawned from necessity. This one is especially guilty of that because this is actually one of the many steps of shaving this yak. This is the biggest step of shaving Dave's 303. Dave's 303 stopped working, and it's primarily an analog device, and I need something that's going to be able to make the analog device do stuff and I'm in the middle of reverse engineering the circuit board. Like this community, everybody's so helpful. Yeah, it's really nice. It's nice to have a good community around. It has very little to do with me. You guys have just kind of gathered around my trash, helping people out. You guys are very good at that. So the typical power supply, 5 units, minimum is 2 to 5, so it could be 3 volts, but we could also run this on 5 volts, and then it's able to withstand the voltage at this stage. So we could have ADS 1152 plugged into L and R. And if it's plugged into L and R, we can measure -10 and 5 and know, well, this thing won't be getting -10 and 5. We can measure -10 and 5, send it to a channel as a waveform with that amplitude, measure maybe the amplitude of the waveform from the PCM, from this thing, and then that would represent our input versus our output scaling in the realm of I2S. And then we can arbitrarily set voltages here as control voltages or waveforms for all 6 of our output channels. But it requires an extra device, which is obnoxious. I don't want to incorporate another op amp because I want to be able to observe things where they are and be able to scale them appropriately. This is getting a little bit out of hand. Auto calibration is one of the features that I want to have on this thing, though. So if I added an ADD, that's what this would do. And that would be I2C, as well as the port expander, which brings us into the next piece of this whole thing. Holy crap. Low drift voltage reference. Of course, that gives me 4 analog input channels that I don't really need, but I don't want to have to scale this thing to 3 volts. We've already scaled it to be sort of 5 volts. It's a pseudo 5 volt device. So this is complicated. Wait, was that another one of those 0.6 of VCCs? Another one of those complicated? No, it's VDD plus 0.3. So it'd be 7 volts plus 0.3. Max of 7 volts plus 0.3. VDD, in our case, is going to be 5. So 5.3 would be our maximum. And currently, when we're doing a maximum voltage level signal, this thing's all powered off. When we are doing a maximum voltage level signal, oops, I just unplugged everything. Everything's lost. Which signal is that? That's not even getting up to 2. Oh, wait, no, this is at a different scale. So this goes up to like 4 volts. So yeah, that would be able to be read by the ADC pretty accurately. Vmax 4.0. Yeah, we go up to 4 volts, so we would then be able to read that completely on this ADC from the 2 channels, from left and right. And we can jump in on our different waveforms with the 2 channels there, and that way we can calibrate both of these channels based on a DC level read, this scaled so that it's outputting at that same level. So you can flip to the DC level, observe it, set it, flip to this, scale, flip to this, scale. Well, we'd have to turn it into a waveform to flip to it. Holy crap. All right, so we've got a plan, and that's something that I want to build. I want to actually put all that together. We need to incorporate I2C, so we're going to work on that tomorrow. We're going to get the ADC running with the rest of the system. Even though it's a 4-channel ADC, we're only going to need 2 channels of it. This is a beast. This thing is pretty much, it's becoming a beast. Yeah. The whole reason for the other ADC is that we can run it at 5 volts. AliExpress for cheap Arduino boards. You got to be careful of knockoffs that may or may not work. We'll have to put the capacitors back into the system too. Because if somebody's just starting out in the whole realm of physical computing, they may not know how to suss out, how to sniff out those counterfeit devices. Although, you know, a lot of the cheaper Arduino stuff does work as well. Arduino's been around a long time, and it's been through several generations of electronics. So some of those newer boards probably work in much different ways than we're used to. A lot of them are very fast. That's what we're running into with this microcontroller, this Teensy 3 point whatever. It's so fast that it's going to be able to do all of this crazy stuff. So tomorrow, we're going to come back here, we're going to hook up the ADC, and we're going to vet it out. We're going to get that thing running, and we'll try to get a readout, and then we'll try to do the loop thing. I'm going to try to put together the algorithm that will be able to vet out and test everything so that I can say, hey, I need a 10-volt control voltage, and it'll be able to output a 10-volt control voltage, and then when I turn the device on in the future, it'll make itself do that again and be all good, right? You should hang out in our Discord to make sure we discover broken hardware for them. Yeah, hang out in the Discord, definitely. I have a Discord. It's relatively accurate. Sorry, relatively active. It kind of goes to bed at night because everybody is European, but you can hang out in there. You can post pictures of animals, or you can ask questions about electronics. There's all kinds of good stuff. If you feel like it, I would love to see you there. I will be back in approximately... Oh, wait, I need to do this. And... No, you're a peon. Let's see. Approximately 20 hours, 4 minutes, and 23 seconds. And we're going to continue on with this mess, this uber mess that we have to deal with here. Thank you guys for joining me. I appreciate having so many viewers. Again, I will be on Discord. I am going to go touch grass. I would suggest you figure out how to do the same for your own good. Otherwise, you guys can go to wherever you need to go on Twitch. And always, always, always remember to never